Some people say programming, others say coding, and some say development. All of this mean the same thing. So what is computer programming? Hi, my name is Obina. Welcome to my YouTube channel. In this tutorial, I'm going to teach you everything you need to know to become a C# programmer. You'll be exposed to fundamental programming concepts using C# and start writing your own applications right away. We'll start learning what programming is and why C#. The difference between C# and .NET framework. We'll install Visual Studio IDE, which stands for Integrated Development Environment, which we'll be using to write and run our code. We'll learn the fundamental concepts of C# programming, where you write a hello world program and create your first C# project. Then we'll learn more advanced concepts like object-oriented programming, and at the end you'll build a number guessing game to help you practice and test your newly acquired knowledge. If you're new to programming or you are just trying to pick up something to add to your knowledge, this tutorial is for you. Please do well to like, comment, and subscribe to my YouTube channel to encourage me to create more quality content like this. So without further ado, let's get into it. What is programming? Programming is writing instructions that a computer will follow to perform various tasks. This basically means that you provide the computer itself instructions that are written in a language that a computer can understand. The instructions could be of various types. A simple one, for example, adding two numbers, or rounding off a number, etc. Or complex ones, which may involve a sequence of multiple instructions. For example, calculating simple interest, given the principal rate and time, calculating the average return on the stock over the last 5 years. Just like we humans can understand a few languages, Igbo, English, French, etc., so is the case with computers. Computers understand instructions that are written in a specific synthetical form called a programming language. There are several programming languages that we can use in order to write code to communicate with the computer. Some of the popular programming languages are C#, Java, Python, JavaScript, C++, and so on. Each programming language has its own syntax or rules that a programmer must follow as they write their code. What is C# and why you should use it? Released in 2001 by Microsoft, C# is one of the most popular and high in demand programming languages in the world. C# is a simple, modern, object-oriented, and type-safe programming language. With C#, your chances of getting a high-paying job as a programmer is very high. More than 17,000 C# jobs are advertised each month with an average salary of $72,000 and above. In the US, there are 6,000 C# jobs advertised for each month with an annual salary of $92,000. Some reason C# is so widely used. It is a modern general-purpose programming language. It is object-oriented. It is component-oriented. It is easy to learn. It is a structured language. It produces efficient programs. It can run on multiple platforms like Windows, Mac, and Linux. It is a part of the .NET framework. It has a huge community support. You can use C# to develop mobile applications, desktop applications, web services, websites, games, virtual reality, database applications, and much more. C# is a high-level language just like Java, Python, and the computer does not understand its source code as it is. So it needs to be compiled to the machine language or binary code that is zeros and ones so the computer can understand the code. A compiler is a program that translates source code from one high-level language to a low-level language to create an executable program. C# programs run on .NET, a virtual execution system called the Common Language Runtime (CLR), and a set of class libraries. Source code written in C# is compiled into an intermediate language, which are stored in an assembly with an extension of .exe for an executable file or .dll for class library file.
And when the C# program is executed, the assembly is loaded into CLR. The CLR performs just-in-time compilation to convert the IL code to native machine instructions. In addition to the runtime services, .NET also includes extensive libraries. These libraries support many different workloads. They are organized into namespaces that provide a wide variety of useful functionalities. Don't worry if you don't understand what these terms I'm using here means. You get to understand them very well down the line as we go through the tutorial. .NET Framework is not limited to only C#. There are other languages that can target .NET Framework and build applications using the framework. Examples of those are F# and Visual Basic. To write C# code, we will need an IDE. IDE stands for Integrated Development Environment. It is used to edit, compile, debug, and run our code. So we'll be using Visual Studio Community Edition. To download Visual Studio, go to visualstudio.microsoft.com/vs/community. Visual Studio is a fully featured, extensible, free IDE for creating modern applications for Android, iOS, Windows, as well as web applications and cloud services. Click the Download Visual Studio button to download Visual Studio. When the download is completed, run the program to install Visual Studio. Make sure you have enough space on your hard drive. It uses a lot of space. Click Continue. Now select the workloads that you will need. Select ASP.NET, select .NET Desktop Development. This is all we're needing to get started learning C#. Click Install. Alright, so after the installation is complete, click on the Launch button to get started with Visual Studio. On the Start window, choose Create a New Project to get started. Here's what we're going to have on the screen. Then if you don't see the options to select Console Application, click on the Install More buttons to get started, so you can choose the things you want to install. But if you see everything here, select Console Application. And there are two console applications to select from. You can select from .NET Core, which is what we're going to be using, or you can select .NET Framework. So let's go ahead and select console application and click Next to continue. Now we're going to enter the name for our project. We will use Hello World as the name of our project. Hello World. Please remember to write it together. And for the solution name, we can decide to use the same name for the solution name, but we don't want to do that. We are going to use C# Basics. So this is the location where our files are being saved on our computer. So if you want to change that, you can select Browse and choose where you want to save your files. Okay, click the Next button to continue. In the additional information window, we're going to select the version of .NET Framework we're going to be using. So let's for the purpose of this course, we can just use 5.0, which is the correct version as at the time I'm recording this video. So let's go ahead and select Create. Our project has been created. Alright guys, Visual Studio has created an auto-generated Hello World program for us. A tradition in programming is when a programmer is learning a new programming language, the first thing he learns to do is to write or print a hello world message to the console window. Right now, as we just created our new project on Visual Studio, Visual Studio has automatically generated the Hello World program for us, and this is what the Hello World program looks like in C#. Here we have about 12 lines of code that just prints Hello World to the console window. Don't worry if you don't understand what is happening here. I'm going to explain them as we progress in this tutorial. What we are going to be concerned with right now is to learn how to run a program using Visual Studio. So to do that, we are going to either use this green rectangle here. When you click this green rectangle, it is going to build and run our program in the debug mode, or you can also use debug. When you click start debugging, your code will run, or you can use F5, or you can also start your code without debugging, that is Control F5. So let us first of all start our code with debugging. Let's click here. Our code ran very quickly and disappeared. Now we're going to try to run this program without debugging, which is Control F5 on Windows or Command F5 on Mac. Let's try and run this program without debugging. And here's what we have. Hello world. Press any key to continue. So this window here that I'm moving around is what we call the console window. So our project is a console application. This is what we are going to be seeing. We're going to be using the console window as an output to our code. We can also use it to input data into our code. Let's hit any key to continue. Congratulations, you've been able to create your first console application project on Visual Studio and been able to build and run your code. Alright, so guys, we've been able to create a new C# console application project and run the program. We've learned how to run a program using F5 to run in debugging mode and Control F5 to run the code without debugging. Now this code prints hello world to our console screen, and this code was generated by default when we created our console application project. So I'm going to try and attempt to explain what this lines of code does line by line. Let's start with the line 1. Using system. Using is a keyword in C# that helps to import the system namespace or any other namespace that you want to import into your program. Now, system is a namespace that lives in the .NET class library. So using system imports classes that are in the system namespace so we can use them in our code. The next line is a blank line. C# ignores white spaces. However, multiple lines makes the code more readable. The next line is line 3, which is the namespace. And the namespace here is a keyword in C# that is used to create our namespace. Now, our namespace here is hello world. And namespaces are used to organize your code. And it is a container for classes and other namespaces. And the line number 4 is curly brace. A curly braces marks the beginning and the end of a block of code. This particular namespace, curly brackets, marks the beginning of the namespace and the end. This is under curly brace. It marks the beginning of the class and the end of the class. This is under curly brace. It marks the beginning of the method. This is the main method and the end. So that's what we use curly braces for. The next line of code is line 5, which is class. Class is a keyword used to create classes in C#. So this is program, the name of the class. The class we use to run the C# hello world program is the program class. Classes are a container for data and methods, which brings functionality to your program. Every line of code that runs in C# must be inside a class. This is what makes C# an object-oriented program, because objects are created using classes. Don't worry if you don't understand how using system namespaces and class works. Just think of it as something that almost always appear in your program, and that you will learn more about them as we progress in this tutorial. The main method, the in line 7 we have static void main, and then some things inside the bracket, so on and so forth. Now this means is if you're coming from other languages, say JavaScript, or also we have functions. Function is a block of code that performs a particular function. Now methods are a type of function that lives inside a class. So in C# we have the main method. Any code inside its curly braces will be executed. You don't have to understand the keywords before and after main. You will get to know them bit by bit while we progress in this tutorial. The line number 7. The line number 7 has what we call the console.writeLine. This is the line of code that does the printing of hello world on the console screen. So this is a class. This console is a class that lives inside the system namespace. And this console class has a method writeLine, which is used to print or output text on the console window, just like we saw when we ran the code. So basically, this is a class that lives inside the system namespace. Matter of fact, if we don't import this system namespace, we will have an error. And this squiggly red line under this console, whenever you're writing a code and you say this, it means that there's an error somewhere. So if we read what the content of the error message is, it says the name console does not exist in this context. So what this means is the compiler does not understand what console means. So we needed to import system namespace by saying using system, or we can also write it like this: system dot console dot writeLine hello world, and our code will still compile and run. Let's try it out. Let's try it out. Hit Control F5, run the program. Okay, see, our code is running very perfectly. There are no errors. In order now to make our code jam-packed, we import this namespace at the top using system with a semicolon. Now, if you notice, this line of code ends with a semicolon. If you don't put this semicolon, there's going to be an error here. So you put a semicolon to end the statement. Semicolon is used to tell the compiler that here is the end of a statement. It serves like the period in when you're writing a sentence in English. Use period to mark the end of a statement. Hello world is also known as a literal. It's a literal because it's just a text, and it's also a string. Strings in C# lives inside quotation marks. What is console? Console is a text-based user interface terminal that comes with your computer's operating system. The console is used to output messages, warnings, and errors, or input textual data into your program as it runs. When you run a C# console application, it invokes the console, which is a low-level command line interface used for communication between user, your application, and the system. Now let's go to Tools, Options, Debugging, and uncheck the option to automatically close the console when debugging stops. Okay, so that we can have a window on and to press any key to enter. In C#, we use the console class to interact with the console. Use the console.writeLine to log a string value to the console. We can print hello world using console.writeLine method, just like we did in the previous lesson. Aside from messages, the console can also display warnings and errors. Warnings are non-fatal messages. Errors can crash your code and cause your code not to compile. The console is a great tool for debugging your code. It will display errors that the program encounters by running your code to give the developer a glimpse of what is going on behind the scene. If something is not right with your code, the first place you will want to look at is in the console to see if any error messages are displayed. Alright, so what is comments? Comments can be used to explain C# code and to make it more readable. It can also be used to prevent execution when testing alternative code. There are different types of comments. In C#, we'll have single line comments, and single line comments start with double forward slashes. This prints hello world message to the console. All right, so this example is a single line comment, and any text between the double forward slashes and the end of the line here is ignored by C# and it will not be executed. This example uses a single line comment before a line of code. Now you can also use comments after the line of code. Say example, this is the right line method of the console class. As you can see, these two comments are valid. We'll have the single line comments and the multi-line comment. A multi-line comment begins with 1// asterisk. This is a program that prints hello world. To the console screen. Is this not awesome? And there you have it. This is an example of multi-line comments. Whether single comments or multi-line comments, it is up to you to choose which one to use. Normally we use single line comments for short comments and multi-line comments for longer comments. You can also use Ctrl+K, Ctrl+C, and Ctrl+K, Ctrl+U to comment or uncomment selected lines of code. Okay, for instance, let's say we want to write another line of code. Maybe write this, comment this thing out, this line of code out, and write it in an alternative way. Let's do that. We say Ctrl+K, Ctrl+C. We've been able to do that with a line comment. So let's come here and write it in another way. System dot console right line, say hello everyone. And this is valid. We are going to comment this line of code, Ctrl+K, Ctrl+C, comment that off, and as you can see, our code is compiled. Let's run this code with Ctrl+F5 and see what we've got. Okay, our code is running very well without the comments showing. So this is how comment works in C#. Comments are used to explain part of code that's difficult to understand. We use it to document the code so that for tomorrow we can understand what is going on in our code. Add comments while you write code and it's fresh in your memory. If you leave comments until the end, it will take you twice as long if you do it at all. I have no time to comment, I'm in a hurry, and the project is delayed are all simple excuses to avoid documenting your code. Some developers believe you should write comments before code as a way to plan out your ultimate solution. Alright guys, to get started with a new section, let us create a new project. To create a new project, go to the Solution Explorer. If you don't see the Solution Explorer, you can find it under View, Solution Explorer, Ctrl+Alt+L. To add a new project, please right click the solution name, go to add the new project. The project we're adding is also a console application, so click the console application and click the next button. Change the project name to variable, because that's what we'll be talking about in this section. Click next to continue and click create to continue. Now we are working with the variable project. So what are variables? Variables are containers for storing data values. Every programming language has variable, but there are slight differences in rules for each language. These rules are what we call the syntax of the language. You can name a variable whatever you choose, but each language has rules for naming variables. In C Sharp, the rules for naming variable are the name can only contain letters, digits, and the underscore character. No other special character is allowed in variable names. The first character must be a letter or underscore. C Sharp is case sensitive with variable names. There's a list of C Sharp words that have special meaning in C Sharp that you cannot use as variable names. Variable consists of two things, a type and a value. In C Sharp, there are different types of variables defined with different keywords. For example, the int type. Okay, now let's show us what the int type is. Remove this code. Here is a structure for declaring and assigning a variable to a value. Where type represents the type of the variable. Variable name represents the name of the variable or the label that points to that value, the label for the variable name, of course. And this equals sign is used to assign value to variable. So we call this equal sign assignment operator in C#. Here is the value that you want to store in this name. So let's go ahead and declare our first variable. To create a variable, you must specify the type. Let's create a variable that's going to store a name. So string. This is the type. Name. This is the variable name is equal to Obina. This is a variable that has been declared and also assigned a value. Now in C#, there are different types of variables defined with different keywords. For example, the string, which is the first one that you just saw. The string, which is this one, it stores text such as name, such as Obina. String values are surrounded by double quotes. Now the next one we're going to look at is the int variable, and they say int x is equal to 40. Now the int represents integer variable. It stores integer numbers. Integers are whole numbers. It stores signed integer numbers. It can store whole numbers of negative type or positive type without decimals. Now the next one is double y is equal to 33.234. Now the variable type is double, which stores floating point numbers with decimals such as 33.34. Now the next type of variable you should know is character. We have character variable, which is written as this, which is equal to C. So character variable stores single characters such as C. Character values are surrounded by single quotes, as you can see. Now let's look at the next variable type, which is bool. It's true. It stores two values, true or false. So in this case, let's say true. So the bool variable type stores only values. So it stores either true or false. You can also declare a variable without assigning the value and assign the value later. For instance, string last name, and I'll say last name is equal to Eze. So in this example, we're able to first of all declare the variable without assigning it, and in this line we now assigned value to the variable. We assigned a value to the variable, or we can call it initialization of the variable. Note that if you assign a new value to an existing variable, it will override the previous value. For example, we already have the name. So let's assign another name to that. Name will now be equal to Sunday. So as you can see, the value of name has changed to Sunday. You can also store a variable into a new variable. First name is equal to name. Another thing that is possible is what we call concatenation. It can do stuff like this: string full name full name equal to first name plus last name. So what we call this is concatenation. You know, when you use the plus sign to add two string values together, this is what we call concatenation. Let's try and display variables to the console. We'll use console, you already know, dot write line. You can say my name is. We'll also use the plus sign to concatenate two string values. So we say full name. Click Ctrl F5 to run the program. Let's see what we've got. Oh my god, this thing is still running the old console. So what we're going to do, if you notice, this hello world is highlighted. So let's try and change the program we want to execute. So let's right click here and go to set as startup project. Once you click here, you notice that the variable here has been highlighted. So when we run this thing again, we'll now be able to run this new project. Okay, so let's click Ctrl F5. Good. My name is Sunday Eze. Did you notice that it's working there, but there's no space between Sunday and Eze? So let's fix that. How do we fix that? We are going to add the space here, plus double quotation mark, space, and another plus sign. And there you have it. Save and Ctrl F5 to run. Good. My name is Sunday Eze. Right, let's continue. The next thing you need to know about variables is constants. You can add the constant keywords to your variables if you don't want others or yourself to overwrite existing values. This will declare the variable as constant, which means unchangeable and read only. For example, to create a constant, use the const keyword, write the type that we want to create the pipe constants, which is equal to 3.14159. And there you have it. Your constant keyword is useful when you want a variable to always store the same value so that others yourself won't mess up with code. You cannot declare a constant variable without assigning the value. If you do, an error will occur. A constant field requires a value to be provided. So as this pi is, you cannot change it to something else. Say 3.24. It's not possible. It's going to show you an error, so it's not possible to do this. Cannot change a const value. Now we've learned how to use the plus sign to concatenate two strings. But for numeric values, the plus sign character works as a mathematical operator. For instance, we have int x equal to 40, and we have double y equal to 3.34. Say double result is equal to x plus y. These x and y are the same values here. X is equal to 40 and y is equal to 33.34. So what we want to do is to add these two values using the plus sign. When we are dealing with numbers in C#, the plus character acts as a mathematical operator for adding two numbers. So now let's log the results of this expression to the console. Let's say console, the right line result. Hit Ctrl F5. 73.34. So let's try other operations that you can do with this. Double, let's do subtraction. sub results. It's going to be x minus y console. Right line, we're going to have sub results. Let's also do multiplication. Multiplication results would not be equal to, we use the asterisk sign for multiplication in C#. For division, we use the forward slash for division when used with numbers is addition mathematical expression. The dash character is subtraction. This asterisk character is multiplication. The forward slash character is division. Let's write these things down. Let's try and log them all to the console. Multiplication, log division, addition results. Plus, so let's do the same for all of them. Let's do the same for all of them. This is going to be subtraction. This is multiplication. And this is division. So Control F5, let's see what we've got. Addition result is 73.34. Subtraction result is this. Multiplication result is this. Division result is this. And if you notice, the results have their various decimal places in place. So you can also declare various variables in one line. Say int A, B, C on one line. This is very possible, and you can also assign same value to all of them at the same time. You can say A is equal to B, which is equal to C, which is equal to 10. This is valid in C#. And let us try and do some maths now. Console, right line, A plus B plus C. Control F5. 30. What did you think happened? 10 plus 10 plus 10 is equal to 30. So guys, there you have it. These are the things you need to know about variables in C#. All C# variables must be identified with unique names. These unique names are called identifiers. Identifiers can be short names like A and B or C, or more descriptive names like age, sum, total value, total volume, total or area. I can say, like I used, sub results, division results. It could be descriptive names like result, and so on and so forth. It is recommended to use descriptive names in order to create understandable and maintainable code. A variable in C# must have a specified data type. And so what is data type? Unlike humans, a computer does not know the difference between 1, 2, 3, 4 and A, B, C, D. A data type is a classification of data which tells the compiler how the programmer intends to use the data that a variable holds. Data types are the building blocks in virtually all computer programming languages. A data type specifies the size and type of values a variable holds. It is important to use the correct data type for the corresponding variable to avoid errors, to save time and memory, but it will also make your code more maintainable and readable. The basic built-in data type in C# are, this is by no means the full list of data types in C#. We have int, we have long, we have float, we have double, we have bool, we have char for character, and we have string. Now the int data type has a size of 4 bytes. It stores whole numbers from -2 billion to +2 billion something. And we have the long data type. It has size of 8 bytes and stores whole numbers from this negative value. It's a huge number, I can't even call it, to this range of positive value. The float is 4 byte in size and stores fractional numbers. It's sufficient for storing 6 to 7 decimal digits. We'll have the double, which stores 8 bytes, stores fractional numbers sufficient for storing 15 decimal digits. We'll have the bool, which is 1 bit. It stores true or false. And then we have the char. It has 2 bytes. It stores a single character letter surrounded by single quotes. We'll have the string. It stores 2 bytes per character. It stores a sequence of characters surrounded by double quotes. Let's begin by learning the number data types. Numbers in general can be divided into 2 types: integer type and floating point types. Integer type numbers are whole numbers without decimal points. It can be negative or positive numbers. Now, floating point type is the type of number with 1 or more decimal points. It can be negative or positive number. C# includes different data types for integer types and floating point types based on their size in the memory and capacity to store numbers. Integral types. Int. The int data type is 32 bits signed integer. Signed here means that it goes from negative values through 0 to positive values. Example, we have int I is equal to 0. We have int year is equal to 2022. We have int temp equal to -4. The int keyword in C# is an alias of system.int32 struct.net. What this means is every data type in C# has an alias name in .NET framework. Basically, to find out the range of a data type and to find out its alias in .NET, let's go into Visual Studio. Now let's create a variable. We'll call it int minimum int. Okay, minimum int is equal to int dot main value. So this is a constant value that is available, which represents the smallest possible value of int. So basically, let's create another one to find out the maximum. Maximum int is equal to int dot max value. All right, so let's put this thing out and see what we got. Console the right line, the minimum value for int is plus minimum int. hit enter to continue, just plus, and the maximum value of int data type is, let's put a space here, is plus maximum int. And there you have it. Let's hit Ctrl 5 to see the results. Okay, let's correct this error, missed A. So good, we've been able to correct that. So basically, if you make any mistake, the compiler will alert you and show you the error message before you even run your code. So it's been corrected, and that red line has disappeared. Let's hit Ctrl F5 to try our code again. Good. The minimum value for int is this, and the maximum value for int is this. So this is how you find the minimum value or the maximum value of any data type in C#. So you call this constant field, just dots minimum value dots maximum value for any numerical data type, because there are other data types that are not numerical. So basically, let's go ahead and find the alias of int in C#. What you do is you say type, call it type equal to type of, you put in the data type there, and then you let's say type dot, see, full name, type dot full name. So this is going to give us the full name of the int data type in .NET framework. So say Control F5, system.int32, that's the name here. So there you have it. So basically, this is all you need to know about the int data type. Control K, Control C. Let's comment this out and talk about the long data type. The long data type is a 64-bit signed integer. For example, we say long seconds make 10 years. It is the number of seconds that makes 10 years, and the value is what, 3 1 5 6. I will have like 7 zeros, 1 2 3 4 5 6 7. For the long data type, we use L as a suffix. It could be small letter L or capital letter L as a suffix, just to tell the compiler, hey, this is a long data type. And the long data type can store numbers ranging from, let's copy this guy, let's copy this whole thing and paste this here and use it to check the long data type. So let's uncomment this. Minimum long, use control, okay, to highlight more than 2 places. To place a cursor in more than 2 places, use control alternate, so you can make changes at the same time. Say long, and then we're going to change these. Okay, so many things to change. Control alternate, hold control alternate and click the various areas where there is int, because you want to change all of them at once for the purpose of this. Every place you have int, you're going to change it to long. All right, so let's clean it up, change it to long, and we are good to go. Okay, these places have capital letter. All right, so we're good to go. Now let's hit Control F5 to see what we've got. The minimum value for long is this, negative this, and the maximum value for long is positive of the same number. Now, the alias name for long data type in .NET is .NET framework is system.int64, and it's showing that yeah, it's a 64-bit signed whole number or integer. So basically, guys, that's all you have to know about the integers we have in C#. There are other ones, but I don't want to talk about those other ones because basically these two are the major integer numbers that we use in C#, unless you want to do some complex computations or you have special needs for other ones. You can go to Google and search for built-in data types in C#. You will see the Microsoft MSDN documentations for all data types you have in C#. Now let's talk about the floating number type. Highlight this and press Ctrl K, Ctrl C to comment them out so that they don't disturb the next lesson. Now let's talk about float. The floats data type can store fractional numbers from, ranging from, let's paste that thing we copied here, uncomment this, Ctrl K, Ctrl U. We have uncommented this. Okay, let us do exactly what we did before. We're going to change this to long. Okay, let's use control alternate and click on the areas we want to effect changes on so that we can be fast. Floats, 2, 3. Let's clean that up. There you go. There's some corrections we need to do here. Use Ctrl F5 to check it out. The minimum value for float is this minus 3.402 up to this number, and the maximum value of int is the positive value of the same number. So the alias name is system.single. This is an example of a float data type. Float, my float is equal to 4.67f. Okay, we use f as a suffix. Without this f, it is going to complain. As you can see, that red line is back again. So we need to put an f to make sure the compiler knows it's a float and not a double, because by default any decimal place number is treated as double. So if you don't put this f here, it will be treated as double. Now the last data type you're going to look at is the double. The double data type. Let's copy this and use Control K, Control U. Okay, Control K, Control C to comment them out. Let's talk about the double data type. The double data type stores larger numbers, larger decimal place numbers. So the double data type can store a range of numbers from, let's do what we've been doing before to find out. Okay, for instance, this is an example of a double data type. Let's write the double example of a double data type. Double double is equal to 3.456. D, we use D to denote the double data type. We use D as a suffix to tell the compiler, hey, this is a double data type. And let's just use Control Alternate click to highlight the areas that you want to change. Where are they? Okay, these two and these two. Let's change that. Good. So let's put double there. double. And there you have it. Let's correct this. Double. And double. 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 I'll be good to go. Is there anything else? Okay, let's check out what is Control F5. Check out what the minimum value for double is minus these values. Very much. The value is way too much, so I can't even. It's very much. And then to the positive side, the alias of double in .NET framework is system.double. The capital letter D, not the small letter d. So take note. There you have it. Now, another thing I want to talk about in this numeric data type is what we call scientific notation. In scientific notation, use E or capital letter E to indicate the power of 10 as exponent part of scientific notation with float or double. Here's an example. Say double D is equal to 0.12 E2. All right, let's log this to the console. See what we got. Let's comment this out. Control K, Control C. Let's hit Control F5. And there you have it, 12. What this means is 0.12 times 10 raised to power 2, which is equal to 12. And lastly, default numbers. Numbers for all number types. Our number type is 0. So what it means is int I is equal to default. Or this we output is 0. Float F is equal to default. We give you 0. It will output 0. The default number for all number type is 0. Now let's look at the booleans. A Boolean data type is declared with the bool keyword and can take the value true or false. For example, bool is data type useful. Takes the value either true or false. So data type is actually useful. So we say true. Another example is bool is programming. Not easy. Not easy. Well, this question is subjective. This is a subjective question, but for me, I would say false, because programming is easy. I hope it's easy to you. I hope you're finding this course easy. Let's try and log what we have on the console. If you notice, when I want to write console.writeline, I use short forms like CW, tap. These are cheat sheets for Visual Studio. You can find some of these things online. Just search cheat sheets or shortcuts for Visual Studio. So console.writeline is data type useful. Now let's hit Control F5 to find out what the result is. True. Something is still on here. Let us highlight some of these things. We're still getting output from this previous. So Control K, Control C. Okay. been able to comment them out. So we got through. Now this is going to output false. So that's Boolean for you. Boolean values are mostly used for conditional testing, which you will learn more about in later part of this tutorial. The default value is default value is false. So what it means is bool, it's bool equal to default. We give us outputs characters. The next data type we're going to talk about is characters, which we use the char keyword to represent. The char data type is used to store a single character. The character must be surrounded by a single quote, like this. For example, char pass grade. What is your pass grade? What is the pass grade in your school? Let me know in the comment section. Let us see what we're gonna get. C. And also the default value is the default value of the child data type is this \0 inside single quotes. So this is the default value. Default value is equal to and the last data type we're going to look at is string. The string data type is used to store a sequence of characters or text. String values must be surrounded by double quotes. For example, we have string greeting is equal to hello world. This is an example of a string data type. Okay, we've done this before. Say greeting. Control F5. Let's see what we've got. A string data type can be a character, it can be a word, or a long passage surrounded with their double quotes. For instance, we can have stuff like this: string as a character, say S. This is valid. String data type, say string word, can be a word, say string. It can also be sequence of characters, a text. This is a string. Can be a passage, can be a whole book. These are all valid string data types. Typecasting. Typecasting is when you assign a value of one data type to another data type. In C#, there are two types of casting. The implicit casting. Implicit casting is done automatically when passing a smaller size type to a larger size type. To understand this very well, let's see an example. Ctrl K, Ctrl C. Let's see an example. Type conversion. The reason why I'm documenting these things is so that you can have them, you have the source code in my GitHub and download it there if you need them. We can also call this typecasting. Implicit casting is done automatically when passing a smaller size type to a larger size type. For example, we can say int my int is equal to 25. And we say double my double is equal to my int. This type of casting is automatic and therefore it is implicit. The compiler did the job for you, trying to convert an int data type to a double data type, and you just assigned it and it happened automatically. Let's try to output these values to the console and see what we're going to get. Say my int, I will say my double, control F5 to see what we got. Same values, 25. We also have the manual type of casting, which we call the explicit casting. This is converting a larger type to a smaller size type. Explicit casting must be done manually by placing the type in parentheses in front of the value. This happens when you try to convert from a larger data type to a lower data type. So you have to do that manually or explicitly. Example, we have double, my double, which is equal to 5.34. Okay, we're having this error because we still have these things here. So let's Ctrl K, Ctrl C, highlights, Ctrl K, Ctrl C to comment them out. So we can use that same type. We can use that same variable without causing errors. So we say int my type, my int my int equal to my double, and you see that red wavy line on the my double is trying to tell you that you cannot implicitly convert type double to int. An explicit conversion is what you need. And how do we explicitly convert? Before the value, inside the parentheses, you put the type that you want to convert to. You've been able to explicitly convert this value to an int. Okay, let's try to output these values. Let's output these values to the console. My double, then my int, and hit Ctrl F5. Did you notice something? We have 5.34 for the double value. We have 5 and nothing else. This is because when you're trying to convert from double or any floating type to an integer type or a number type, you lose some data. You lose the decimal place. The int data type is a whole number data type. So whenever you're trying to convert from a floating point number to an integer number, basically you're going to lose some information. You're going to lose some data, as you can see in this place. So that's why you have to be very careful whenever you're trying to convert from one type to another. You have to be sure what you're doing. This is exactly why the compiler is telling us no, we will not do this automatically. So be sure you are doing this yourself. If you're losing any information, it is not the compiler's fault. You did it intentionally. And so having said that, let us output the order with which you can do an explicit conversion. Say you can convert from double explicitly to float. This is the direction it goes. You can convert from float to long. You can convert from long to int. and then finally from int to char. You may be wondering why char? Why, how is char? Is char not a character data type? Is it a number data type? Yes, it's a good question you have there. Every character in C sharp, say A or B or C, they have an equivalent integer number value. So basically, whenever you convert from char to integer, what you're going to get is the number value. As you can see, this is in their order of double is bigger than float, and float is larger than long, and long is larger than int, int is larger than character. So this is the order. There's order. Let's do that for the implicit conversion. We're going to have the char, which is the lowest of them all, to can easily convert to int without an error. You can convert from int to long automatically. You can convert from long to float without compiler crying. You can convert from float to double, and there won't be any problem. This is the order with which you can convert data types. Now the question you may be asking is, why do we need conversion? Many times there is no need for type conversion, but sometimes you have to. So in the next section, we are going to find out the usefulness of type conversion. And also there are other ways to do this conversion. You can convert data types explicitly by using built-in convert methods, such as we have convert to Boolean. We have convert to double. We have convert to string. Convert to int 32. Did you see where this C# alias is being used? So you should know the int 32 is the same thing as int. So the int 32 is just the .NET framework name for int in C#. You can also convert to int 64, which is the same thing as long. So let's do some example. Say string, my string is equal to true. Okay, we'll have some character, my child equal to a, and then double, my double to 3.5. Let's log some conversions. Okay, I think we need to comment these guys out so we don't see an error. All right, so let's try to convert. Let's convert this double to int 32. See what we're gonna get. Say convert dot to int 32, and what do we want to convert? We want to convert my double. Let's convert my double to int 32, and let's convert string. Convert to string to string. And the value we're going to convert to string is the character. Let's convert the character to string. My char. Oh my god. My char. That's what I wanted to write. So let's fix that. My char. And then finally, let's convert the string to Boolean. Convert the to Boolean. To convert my string to Boolean. Let's see what we're gonna get. Hit Ctrl F5 to run your program. Alright, so guys, we were able to convert these things to different data types. Did you see what happened? We had 3.5 as a double, but when we converted it to int, it was approximated to 4 because integer data types do not store decimal places. So what it does is it rounds it off to the nearest whole number. Our character is now a string. It returned A. This is a string value that started with small letter t, but it was converted to a Boolean. And now the value is true with a capital letter T. So it's no more a string, it's now a Boolean value. You may be wondering, why do we need conversion? Why convert when we can always select the data type we want to use? Actually, most times there's no need for type conversion, but sometimes you just have to. In the next section, we're going to learn why we need data type conversions. Let's talk about numbers in C#. Number types are divided into two groups: the integral types or the integer types, which stores whole numbers, positive or negative, such as 1 2 3 or -4 5 6, without decimals. Value types are int or long, as in here. So we already have an idea of what their maximum and their minimum values are. Which type used depends on the numeric value. If you want to save a very large number, you use the long type. If you want to save numbers that are not so long, this is 32 represents the 32 bits. This represents 64 bits. So the one you use depends on the numeric value you want to store. Then the floating point types. Floating point types represent numbers with a fractional part containing one or more decimals. Now we have double, and the type you use depends on the value you want to store. Basically, what this means is the int value has a memory of 4 bytes, while the long has a memory of 8 bytes. This can store more numerical number values. It has wider range, and this one has lower range to save memory. And so is the float and the double, so you can use any of them to save memory. Even though there are many numeric types in C#, the most used for numbers are integer for whole numbers and double for floating point numbers. In general, and in our tutorial, the int data type is the preferred data type where we create variables with a numeric value. As you should use a floating point type whenever you need number with a decimal. One thing I didn't add to this place is how to declare a variable, a floating type value. Okay, this is how to declare a floating type variable. Say my float number is equal to 3.245 f. You cannot declare a floating number without adding this f. It could be small letter f or a capital letter F. So this is required, to tell the compiler that you are trying to save a float. Alright, so guys, in this lesson, we're going to learn how to get user input. Okay, so you've already learned that console.writeLine is used to print text on the console. Now we're going to use console.readLine to get user input. So let's try some example. Enter your name. I'm going to ask the user to enter the name. So let's create a string variable and get user input from the keyboard and store it in the variable string name. String name equal to console.readLine. And finally, let's try and display what the input the user gave to us back to the user. your name is. And once done, you hit Ctrl F5 and we are going to get application started. Enter your name. Maybe now hit enter. In this example, we ask the user for their name. Use console.writeLine to print, enter your name on the screen, and then the next line is going to allow the user to enter some characters, which is a string. So console.readLine returns a string. So whatever it is you typed in there will be registered and stored in the name variable. So what we now did is we outputted the value on the name variable to the screen. The console.readLine method returns a string. Therefore, if you're trying to get a numeric value from it, where the data type is any of the number data types, say integer, you'd get an error. For example, let's say what is your age? Age is equal to console read line. Your age is plus age. Already before we even try to run the application, the Visual Studio compiler is already telling us that, hey, there's an error here. We can't do this. With this wavy red line that is under this place, it is telling us that we can't represent an integer with a string. This is a string. Whatever comes out of this method is a string. So we can't use an integer. So now what do we do to fix this logical error? You guessed it, type conversion. Let's go ahead and convert the input string to our variable type. Convert dot to int32. Everything that is inside this guy, whatever this guy is going to return, we're going to convert it to int32, and the compiler is happy. Our code is compiled. So now let's run it and see what we got. Enter your name. My name is Obina. What is your age? My age is 83. I'm 83 years old. Please do not tell anyone. That's my age. Your age is 83. So you see, it's working as it should because we've converted the user input to a workable one. So now what if you enter a wrong input? For example, let's hit Ctrl F5 and say, okay, Obina, for age, what if we enter, say, a character or a string, say a combination of both? What are we going to see? We're going to get an unhandled exception. User input has stopped working. You get an exception, unhandled exception. System.format.exception. Input string was not in the correct format. So you will learn more about exceptions and how to handle them as we progress. Operators are symbols that are used to perform operations on operands. Operands may be variables or values. In mathematics, the plus symbol do the addition of the left and right numbers. In the same way, C# includes various operators for different types of operations. For example, int x is equal to 2 plus 3. Here we use the plus operator to carry out addition operation, while 2 and 3 are operands. So basically, if we output the value of x, which is the result of the operation, we are going to have Ctrl F5 we're going to have 5. Although the plus operator is often used to add together two values, like in this example, it can also be used to add together a variable and a value, or a variable and another variable. For example, we can say int summation1 is equal to 40 plus 60, which is going to output 100. And we're going to have and next we have int sum2 equal to sum1 plus 200, which is going to give us an output of 300. And lastly, we have sum3 equal to sum2 plus sum1, which is going to output 400. Some operators behave differently based on the type of the operands. For example, plus operator concatenates two strings. For example, let's say string 1 is equal to hello, put some space here, plus world, already know, so this is what we call concatenation. Let's say we output this one to the console. What we're going to get is hello world. There you have it, hello world. This operation is what we call concatenation. When you use the plus operator on two strings, you join the words together. So you can also concatenate two variables, say string greeting equal to hello, let's declare another variable name, and then we want to declare the third variable, grade2, but greeting plus name. Remember to add space here, and let's put that out in the console and see what we got. Grade2. Hit Ctrl F5 to test your code. All right, we have hello world, hello Obina. So the concatenation is working perfectly. So in C#, there are different categories of operators. Let's look at them one after the other. We have arithmetic operators. Arithmetic operators are used to perform common mathematical operations on their operands. Here is a list of operators, mathematical operators. We have the plus, or we call it the addition operator, which adds together two values. Example, x plus y. And we have the subtraction, which subtracts one value from another. Example, x minus y. We have the star or the asterisk operator, we call it multiplication. It multiplies two values. We have the division, which is a forward slash, and it divides one value by another. Example, x divided by y. We have the modulus operator, which returns the division remainder. We use the percentage sign to denote the modulus operator. What it does is it returns the division remainder. We'll have the increment operator with two or double plus sign. It increases the value of a variable by 1. And we'll have the decrement operator, which decreases the value of a variable by 1, which is, double subtraction sign. C# assignment operators. Assignment operators are used to assign values to variables. Example, int y is equal to 5. So in this example, we used the assignment operator to assign the value 5 to the variable y. We also have what we call the addition assignment operator, which adds a value to a variable. Example, int z is equal to 10, and then we'll have z plus equal to 5. This operation will result to 15 because plus equal to means same thing as z equal to z plus 5. Here is a list of all assignment operators in C#. We'll have the normal assignment operator. We have plus equal to, minus equal to, times equal to, and there's, which is same thing as s equal to 5. There you have it. All right, so the next thing we're going to look at is the comparison operators. The comparison operators are used to compare two values. We have the equal to, we have not equal, greater than, less than, greater than, or equal to. We have less than or equal to. Now finally, we are going to look at the logical operators. Logical operators are used to determine the logic between variables or values. So we have the logical AND, which returns true if both statements are true. The logical OR returns true if one of the statements is true. Finally, the logical NOT reverses the results, returns false if the result is true. We'll learn more about comparison and logical operators when we get to the Booleans and if-else section of this tutorial. The C# math class has many methods that allow you to perform mathematical tasks on numbers. For instance, we have the maths.max class, which takes in two parameters, x and y, or we could call it two arguments. And the maths.max class method can be used to find the highest value between x and y. For example, maths.max 5, 10, 10. This is going to return the highest value. Now let's assign this to a variable. Say, let's call it the max, right? Let's call it the max. And then let us output this value. All right, so we hit Ctrl F5 to run the program. And we have 10. 10 is the maximum. We have other methods like maths.main, and this returns the lowest value between x and y. Okay, we have other ones like math.sqrt x. As you already guessed, we have the math.ebs, This method returns the absolute value of x. Absolute here means the positive value of x. For example, say we have int x is equal to minus 6. So we want to return the maths dot abs of x. This is going to wipe out the negative value and return the positive value of x, which is what we call the absolute value of a number. So it removes the negative value and returns a positive value. And finally, we have maths.round. Method. This method rounds a number to the nearest whole number. For instance, we have math.round. We want to round 9.99. Guess what this is going to give us? Okay, let's wrap this around. Okay, this is cw. Let's round this side here. Let's put it aside there. And so what we're going to get, Control F5. Guess what we're going to get? 10. We got 10 because it rounds it to the nearest whole number.
Strings are used for storing text. A single variable contains a collection of characters surrounded by double quotes. Example, let's create a variable of type string and assign it to a value created. Let's create a variable type string. Greeting, and assign it to a value. So hello. A string in C# is actually an object which contain properties and methods. It can perform certain operations on strings. For example, the length of a string can be found with the length property. String text is equal to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, let's have the full alphabet for our example. Let's say console the right line the length of the text string is text dot length. It. Okay. There should be a plus sign here to concatenate this variable. Alright, so let's hit Control F5 to run our program and see what we've got. The length of the text string is 26. Good, and that's correct. That's the length of a full alphabet in English language. There are many string methods available. For example, we'll have two upper and we have two lower, which returns a copy of the string converted to uppercase or lowercase. For instance, let's have another string. Say great. Say good morning. Now let's turn this to an uppercase or caps. So we say great
dot swapper. It's Control F5. See, good morning is in all caps right now. No, let's try to lower with that. Let's try without text variable. So text that's lower. Control F5 to run our program. As you can see, our alphabet is now in lowercase. So basically, these are the basic methods that we have in the string object. Another thing we need to know about the string is what we call the string concatenation. The plus operator can be used between strings to combine. This is called concatenation. Example, we'll have string first name equal to opener string last name equal to exec. Now let's try and concatenate the first name and the last name together so we can have first name plus last name. Let's add some space here. It is now up. There's on the console. It's Control F5 to run. Would be nice, Dave. There you have it, would be nice as the final output. And also notice that we have added a space after Ubin to create a space between first name and last name. You can also use the string.concat methods concatenate two strings. You can use the string.concat method to concatenate two string. Let's say we'll have string name2 is equal to string concat first name and last name. Yeah, last name. Just hit Control F5 to run the program. Have it. It's the same thing. The string has been concatenated. Another option of string concatenation is string interpolation, which substitutes values of variables into placeholders in a string. You don't have to worry about spaces like with concatenation. For instance, let's say string name 3 equal to my full name is you open and close an angle bracket, first name open and close the curly brackets, say last name. It's a semicolon. Now come to the beginning. Just before the first quotation mark, you add the dollar sign. Have it. This is what we call string interpolation in C#. Now let's log this on our console, see what we got. Name 3. Control F5 to run this program. My full name is Ubinaize. There you have it. That you have to use the dollar sign when using the string interpolation method. String interpolation was introduced C# version 6. You can access the characters in a string by referring to its index, not inside square bracket. String indexes start with 0. Index 0 is the first character, index 1 is the second character, and so on and so forth. Okay, let's create an example. String is equal to so let's try so my string we use square brackets to denote the index. Let's say what we're going to get at the 0 index. At the 0 index age. Let's say I want to find the one at the index 1 and the letter at the index O. You can also find the index position of a specific character in a string by using the index of method. For instance, say my string the index of open and close bracket. Then we can now add character that we're looking for its index. Now let's look for the index of P in my string. Control F5 to run the program. And the index of P is 2. So you can find the index of a character, or you can also find character index. You can find a character on a particular position using int. Another useful method is substring. Substring extracts the characters from a string, starting from the specific character position or index, and returns on string. Example. Full name is equal to Naise. Now let's get the location of the letter E. Save it integer, go to type, and character position is equal to full name dot index of E. Now let's get the last name. So with this, we can actually go ahead and say full name dot substring. Again, the substring starting from the position. You already know we've got now character position. That is the last name. Okay, we've had variables saved before, so let's start the last name one. Let's log what we have. Last name 1. Control F5 to run the program. We've been able to print the surname using the substring method. Because strings must be written within double quotes, C# will misunderstand this and generate an error. For instance, let's say string tst equal to you are the real. You are the real MVP for getting this far. So guys, you are the real MVP for getting this far. As you can see, we already have an error because C# does not understand what is going on here. You can have a double quote inside a double. So to avoid this problem, we use backslash escape character. Here it is. You just add a backslash here and add a backslash here. You'll be able to escape this character. So for each character that is not acceptable inside a string, you can use the backslash to escape the character. And here are some of the characters that you can escape using the backslash. Okay, so for a single quote, this way insert single quote, in a string. This way insert a double quote. String. And finally, so we'll insert single backslash in a string. C# uses plus operator for addition and concatenation. So remember, the numbers are added, strings are concatenated when you're using the plus sign. For example, with int x is equal to 5, int y is equal to 3. We'll have x plus y, which is going to output the sum of these two numbers, which is 8. But then if you add two strings, the results will be a string concatenation. For instance, let's say string x1 is equal to say 5, string x2 to 3, you have x1 plus x2. What do you think we're going to have? Your guess is as good as mine. We're going to have is a string. We're going to have a 5, 3, which tells you that the plus operator operates on string differently and operates on numbers differently. So use this plus operator with care. Very often in programming, you will need a data type that can only have one of two values, like yes or no, on or off, true or false. For this, C# has a bool data type which can take the values true or false, Boolean values. A Boolean type is declared with a bool keyword and can only take the values true or false. For instance, we have bool is C#. Of course, C# is false, so let's say true. Another example, bool is bitter color sweet. Going by the name, it's can be sweet, something that is bitter. Let's log this to the console. True. A Boolean expression is a C-sharp expression that returns a Boolean value, true or false. You can use a comparison operator such as the greater than operator to find out if an expression or a variable is true. For instance, we have int a equal to 30. Int b equal to 15. Now let's log the value of a greater than b. See what we got. Hit Control F5 to run the program. This returns true. This is true because 30 is greater than 15. We can also reverse this and say a less than b. Trying to do a check here. False, because 30 is not less than 15. So this is what we use the comparison operator to do. Another we can look at here is another operation with Boolean. Another Boolean operation is console the right line x equal to 9. So this is going to ask the compiler what is x with not given x value. Say x int x is equal to 9. Hit Control F5. You're going to get true because yes, they are equal. If you change the value of this to say 5 and hit Control F5, you're going to get a false because they are not equal. So double equal sign checks for equality of value. The Boolean value of an expression is the basis for all C-sharp comparisons and conditions. You will learn more about conditions in the if-else statements. C-sharp supports usual logical conditions from mathematics. Less than a is less than b, less than or equal to a is less than or equal to b, greater than a is greater than b, greater than or equal to a is greater than or equal to b, equal to a is equal to b, not equal to a is not equal to b. You can use these conditions to perform different actions for different decisions. The if statement. The if statement is used to specify a block of code to be executed if a condition is true. Here's the syntax. If condition, some block of code to be executed if the condition is true. Also note that if is in lower letters. Uppercase letters if or if will generate an error. So let's go ahead and test two values to find out if 20 is greater than 15. If the condition is true, then we'll print some text. If 20 is greater than 15, open curly brackets. If you can remember, curly brackets are used to enclose a block of code. So inside these curly brackets, we're going to write some block of code that this will run, that the compiler will run if the condition is true. So 20 is greater than 15. Let's hit Ctrl F5 to run the program. Okay, remember to put your semicolons. Okay, hit Ctrl F5 to run the program. 20 is greater than 15 indeed. So this works with variables too. Let's say int x equal to 20 and int y is equal to 15. So if x is greater than y, x is indeed greater than y. True. F5 to run. There you have it, x is greater than y, because the condition was true. If the condition was false, that code would not run. What if the condition is false? What do we do? This block of code would not run. And that brings us to the else statement. We use the else statement to specify a block of code to be executed if the condition is false. And the syntax is if condition, block of code to be executed if the condition is true, else block of code to be executed if the condition is false. So now let's go ahead and try some things. Another example, let's say int time equal to 20. Now if time is less than 12, if time is less than 12, we say good morning, else meaning if time is 12 or anything greater than 12, we say good evening. Say good evening. And so our time is 20. So let's run this and see what we're gonna get. Good evening. 20 is greater than 12. 20 is greater than 12, so we have good evening. Here time is greater than 12, so the condition is false. Because of this, we move on to the else condition and print to the screen good evening. If the time was less than 12, the program would print good morning. The else if statement, we use the else if statement to specify a condition if the first condition is false. So the syntax goes like this: if condition 1, block of code to be executed if condition is true, else if condition 2, block of code to be executed if the condition is false and condition 2 is true, else block of code to be executed if the two conditions, condition 1 is false and condition 2 is false. So let's have an example. Int what's 15? So if time 2 is less than 12, we'll say morning, else if put another condition, time is less than 18, what are we going to say here? We're going to say good afternoon or good day. Say good day. And else. Finally, if none of these conditions are true, then we say good evening. Good evening. So in this example, time is 15 and of course it's greater than 10. So the first condition will not run, obviously. The next condition in the else if statement is true. So we're going to print the good day. It's going to print the good day and breaks out of the operation without stepping into the else block. However, if the time was 20, our program would print good evening. So let's run it and confirm. Control F5. Good day. There you have it. There is also a shorthand if else, which is known as the ternary operator because it consists of 3 operands. It can be used to replace multiple lines of code with a single line. It is often used to replace simple if else statements. The syntax is variable equal to condition, question mark, expression true, expression false. So basically, instead of writing this, let's copy this code and transform it. Instead of writing this block of code right here, let's kind of transform this code. So writing something like this, let's transform this to something else. Let's store our variable as results. So we're going to have time is the condition. If time less than 12, with a question mark. If it's true, we're going to say good morning. Apostrophe. Then we say good day if it's false. There you have it. Now let's run our program. Let's log this to the console. Control F5 to run the program. Good day. So that means time is 20, time is not less than 12. There you have it. Let's say we change this time to say 10. Here's Control F5. Here's Control F5. Switch statements C#. The switch statements is used to select one of many code blocks to be executed. The syntax is switch. You put in some expression, case X, code block break, case Y, code block break. The switch expression is evaluated once the value of the expression is compared with the values of each case. If there is a match, the associated block of code is executed. The break and default keywords will be described later in this section. Here is an example that uses the weekday number to calculate the weekday name. And day equal to 3. Okay, I'll have a switch. Looking for variable in the switch is day. That's the expression of case 1. Block of code. 1 is Sunday. Right? Case 2. Monday. Case 3. Case 3 is Tuesday. We'll have to break out of this condition. It's a case for Wednesday. I have 5, 6, 7. So let's copy this 3 and use them. Case 5, case 6, and case 7. Say Wednesday, Thursday, Friday, Sunday, Friday, Saturday, sorry, Saturday. All right. Saturday is the 7th day of the week. So if we run this code, F5, our day is Tuesday. Tuesday is the 3rd day of the week. So if we enter another value, say the 5th day. All right, so Thursday is the 5th day. So let's get the 6th day of the week. Hit Ctrl F5. We're gonna get a Friday. So there's it. Once C# reaches a break keyword, it breaks out of the switch block. This will stop the execution of more code and case testing inside the block. When a match is found and the job is done, it's time for a break. There is no need for more testing. The default keyword is optional and specifies some code to run if there's no case match. For instance, say int day. We used day before, so let's say capital day. Let's capitalize this particular variable to make it work. Let's go to say day 5, and we're going to have our switch statements. I will switch day. Going to switch day. Say case 7. If it's weekend, say today is Saturday. Today is Saturday, it's weekend. It's weekend. Break. Remember to include the break statement in your code. Case 1. Today is, let's copy this, paste here. Today is Sunday. It's weekend. Break. And finally use the default case. Which will resolve any other case to this default solution, which is looking forward to the weekend. Remember to use the break keyword also. Alright, so let's hit Ctrl F5 to run our code. Looking forward to the weekend. If we change this code to say 7, hit Ctrl F5. We're gonna get this. Today is Saturday, it's weekend. Loops will continue to execute a block of code as long as a specified condition is reached. Loops are handy because they save time, they reduce errors, and they make code more readable. C# while loops. The while loop loops through a block of code as long as the specified condition is true. Here is the syntax. Now let's look at an example. And let's first of all declare a variable. I make it equal to 0. Then we can say while We'll give it a condition. I is less than 10. Then inside this bracket, we'll put a block of code that will be executed while the condition is true. So let's log the values of I to the console. Why I is less than 10. So the next thing we're going to do to keep this loop running is to increment the value of I. I'll say I++. Just like we learned in our operator session of this tutorial, I++ is the same thing as I equal to I plus 1. The I++ operator, the plus operator is what we call the increment operator. It adds, or what we'll call, the increment operator, it adds +1. It adds 1 to a particular number. So basically our code is run. Our code is set. All right, so let's hit Ctrl F5 to run our code. Our code has finished running. As you can see, our code ran. For each line, it printed out the value of I. Now, let me try to explain what happened here. Initially, we gave I the value of 0. So within the condition of our while loop, we said yi is less than 10. So we print the value of I. The first value of I was 0, so we printed 0. And then we increase the value of I to 1. And then the while loop comes back again to this position and checks the condition. And I, which is now equal to 1, is still less than 10. It goes again, prints I, which is 1. And that's how it started printing from 0 to 9. You shouldn't forget to increase the value of variable used in a condition, otherwise the loop will never end. You should always increase the value of I so that it can meet the termination condition. The termination condition is I equal to 10. Once I is equal to 10, this loop will stop running. But if you forget this line of code where we increase the value of the variable, it's going to run forever because I is less than 10, which is 0. It's going to continue to run until your program crashes. So remember that. Now, apart from the while loop, we also have the do while loop. The do while loop is a variant of the while loop. This loop, we execute the code block once before checking if the condition is true. Then it will repeat the loop as long as the condition is true. Here is the syntax. Now let's see an example. Say, okay, do loop. While loop. All right, so let's see an example of the do while loop. Let's begin by instantiating variable I and giving it a value. Okay, because we've used that I before here, so it's giving us error. Let's say k. Let's say k could be any variable. Okay, let's say int k. So let's say do inside we will put the code block to be executed, which is so right line. We'll enter the value we want to print out, which is k. Sorry, not I, k. Just k. Then we increment the value of k. So the last part is the condition. So the condition is yi is less than 10. Remember to put semicolon here. Let us stop this code from running. Let's highlight it. I hit Ctrl K, Ctrl C to comment that out so that we can focus on this particular code. And as you can see, I did a mistake here. Let's correct that mistake. It's supposed to be K. And then let's run our code. Control F5. You see, 0 to 9, the same thing. YK is less than 10. So as you can see, the do while loop will always be executed at least once, even if the condition is false, because the code block is executed before the condition is tested. Okay, for instance, let's say YK is greater than 10, which normally it's not supposed to run because K is 0. So K is greater than K is never greater than 10. So let's try and run this code. Note it's going to print 0, which is the first iteration. You see, it ran first and printed 0. After the increment, K became 1, so it can't run again because K is never greater than 10. So put that into consideration while you want to run, when you want to choose the type of while loop you want to use, whether the normal straight while loop, which is this one, which never executes anything except the condition is true, or the do while loop, which is going to run once. It is going to do the first iteration before any increment, before any check. When you know exactly how many times you want to loop through a block of code, use the for loop instead of a while loop. Here is the syntax. Statement 1 is executed one time before the execution of the code block. Statement 2 defines the condition for executing the code block. Finally, statement 3 is executed every time after the code block has been executed. For example, we have for int I equal to 0. This is the first statement. I is less than, let's say 5. Second statement, then I plus plus the last statement. So inside the curly braces, let us log this to the console. Let's log the value of I to the console. Let's see what we got. Control F5 to run. We'll have values 0, 1, 2, 3, 4. So basically, the first statement sets a variable before the loop starts. It initializes a variable with the value 0. And then the second statement defines the condition for the loop to run. I must be less than 5 for the loop to continue running. So if the condition is true, the loop will start over again. If it is false, the loop will end. Now, statement 3 increases of value I plus plus, which each time the code block in the loop has been executed, this guy will now run. That means the first statement runs first, the second statement then runs if this condition is true. Now, after that, then the statement runs and increases the value of I. All right, so let's look at another example of for loop. Second example. Let's make a for loop to print even numbers between 0 and 10. For and I is equal to 0. I is less than or equal to 10. Less than or equal to 10. So that means it's either I is less than 10 or I is equal to 10. So that means 10 is inclusive. And then I, the last statement is going to be I plus 2. Because here we're trying to print even numbers between 0 and 10. So I is 0. I plus 2 is 2. So 0 plus 2 is 2. Then the next time I increases, 2 plus 2 is 4. So that is what we're going to do right here. Let's now plug this to the console. Value of I is equal to, there's a mistake here, I is equal to I plus 2. We're trying to give it a value, just don't add 2 plus like that. So there's another way we could write this, and it is I plus equal to 2. It is something as I equal to I plus 2. So basically, let's run this program and see what we've got. Let us highlight that and press Ctrl K, Ctrl C. For Windows, you can use Command K, Command C for Mac to comment that out. So now let's hit Ctrl F5 to run our program. Starting from 0, 2, 4, 6, 8, 10. These are all even numbers starting from 0. So you can start with 2 if you want to start with an actual even number. Start with 2. Let's hit Ctrl F5. See what we've got. See 2, 4, 6, 8, 10. There is also a for each loop, which is used exclusively to loop through elements in an array. You may be asking, what is an array? An array is a data structure representing an ordered collection of values or objects, or we call elements, of the same type with a fixed length. Each element has an index or key that define its position in this collection. We'll look into arrays in the next or in the coming section of this tutorial. Here is the syntax for a for each loop. The following example outputs all elements. Okay, now let's look at an example. Let's look at an example of for each. Let's create an array first. This array has the data type of string. If you want to create an array, we use these square braces. So paths, that is the identifier for the array, equal to curly open curly braces. First item, the first element in our array is a dog. Put a comma, put a card, because the string has to be in double quotes. It has to be in double quotation marks. So next one is fish. And some people use fishes as pets. The next one is monkey. Okay, I think that will be it for our array. Is a pet array. Now we want to loop through this array and print out this data on the console. So to print out these elements on the console, so how do we do it? We use the for each loop. For each, okay, open string pet in pets. See how simple it is. The for each loop it reads like a plain English, so we want to output each pet in the array. So for each string pet in pet, collection of different pets, and the string pet is a single pet in pets. For each of them, print them to the console. That is what this is. And let's highlight that and hit Ctrl K, Ctrl C to comment that out. You can use Command K, Command C on Mac. All right, let's hit Ctrl F5 to run our program. Good. We have dog, cat, fish, monkey. It's been listed out. That's what we use the for each loop to do. Don't worry if you don't understand this particular example, because I understand that you don't know what an array is. We've never talked about. We're going to talk about this arrays in the array sections very soon. We're going to talk about arrays. Let's comment this out too. Okay, let's talk about the C# break and continue keywords. I have the break and continue keywords that is used with arrays, that is used with loops, the while loop, the for loop. We can use the break and continue keywords to, add some dynamics to the flow of our loop. So you've already seen the break statements used in the switch statements. Of course, you've seen that it was used to jump out of a switch statement. The break statement can also be used to jump out of a loop. For example, we have four ints I equal to 0, I is less than 10, I plus plus. What did I do? So now, if let's put a condition, you already know this. If I is equal to 4, what do we do when I is equal to 4? We break. What this break does is it jumps out of the loop and stops the loop. So if not, if this condition is not met, we'll continue printing the value of I on the console. So let's hit Ctrl F5 to run this program and see what it's going to give us. There you have it, 0, 1, 2, 3. So when the condition was met, which is I equal to 4, it broke out of the loop. So that's how we use break statements in a loop. Now let's talk about the C# continue keyword. Continue keyword. The continue statement breaks one iteration in the loop if a specified condition occurs and continues with the next iteration in the loop. Unlike the break statement which stops the loop entirely. Let's take for instance for int I is equal to 0, I is less than 10, I plus plus. Good. So if let's put a condition there, I is equal to 4, what do? We continue. If not, we continue logging the value of a variable I to the console. Let's hit Ctrl F5 and see what this code is going to do. Comment this guy out. Ctrl K, Ctrl C. Alright, so let's run this program. Ctrl F5. We have 0, 1, 2, 3, 5, 6, 7, 8, 9, 4 disappeared. So what happened there is our for loop is running and it got to a point where I is equal to 4. It continued. It didn't have to run. It jumped that particular iteration and continued with the other ones. So that's what we use continue statement for. You can also use the break and continue keyword in while loops. For instance, let's check the break keyword in while loop. Let's look at an example of the break keyword in while loop. So int I is equal to 0, while I is less than 10. Let's print the block of code. Let's log the value of I to the console, and after that let's increase the value of I, and then let's do a check. if I is equal to 4, if true, then we should break loop. Let's hit Ctrl F5 to run this program and check it out. There you have it, 0 to 0, 1, 2, 3. When it got to 4, it broke out of the loop. Let's check the continue keyword. Let's check an example of the continue keyword in the while loop. In the while loop. So example is int I got to 0. But then let us go ahead and comment this out. Int I is equal to 0. I is less than 10. First of all, let's do our check. If I is equal to 4, if true, we can say I plus plus and continue. We increment the value immediately and continue. That means we've jumped the value of 4. And then outside the if condition, we print the value of I to the console. And then increase the value also. Why are we increasing value 2 times? This loop is going to run when the value of I is 0, because that's the starting point. When it gets to this point, it will check 0 is equal to 4. Say it's 4, so this block of code right here will be jumped. And it gets to this place, prints the value of I, which is 0, and increases the value of I to 1. It will go again until it gets to I becomes 4. When I is equal to 4, it will enter into this block of code, and then before anything, it increases the value of I to 5 and continue. This continue is going to leave this part of the code and start from where I is equal to 5 and continues again and again and again. That will have you eliminating the value of 4. Let's hit Ctrl F5 to run our code to check it out. There you have it, 0, 1, 2, 3. 4 is omitted. Goes continued. 5, 6, 7, 8, 9. Arrays are used to store multiple values in a single variable instead of declaring separate variables for each value. To declare an array, define the variable type with square brackets, string, square brackets, give it a name, pets. Now we've declared a variable that holds an array of strings. To insert values to it, we can use an array literal, place the values in a comma separated list inside curly braces. Here's how to do that. Say dog, cats, fish, and monkey. To create an array of integers, you can write int square brackets. Let's call this my num. Let's give it a value of 3, 7, 10, 4, 11. We didn't have to put the double quotation because it's an int. All right, so you can access an array element by referring to the index number. Let's say we want to access the value of the first element in pets. Let's say pets, square brackets, open 0, square brackets closes. So with this, we can access the first element in the pets array. So the index of an array starts counting from 0, 1, 2, and n. So basically, the 0th index is the first item or element in the array. Let's hit Ctrl F5 to read out the 0th index of the pets array. See what we got. Print it to the screen. They've got it. Dog. 0 is the first element. So to access the second element, we can put 1. It's Ctrl F5. And we'll have cards. So to change the value of a specific element, we'll refer to the index number of that element. So for instance, if we want to change the value of the third element of the pets array, this is how we'll go about it. Let's say pets. The third element is added at index 2. So we're going to change it to, say, tiger. Yeah, you might be surprised. A tiger can be a pet also. Some people have tigers that are trained to be a pet. So would you like to have a tiger as a pet? Let me know in the comment box. So to find how many elements in an array, we use the length property. For instance, let's find length of the pets array. Let's say let's put this inside this guy. Let's put this inside here. So here's Ctrl F5 to read 4 elements. Well, 4 elements in the pets array. Another thing we need to know about arrays is you can loop through the array elements with a for loop and use the element and use length property to specify how many times the loop should run. The following example upholds all elements in the pets array for int I equal to 0. So we're starting from the 0th index and I is less than pets.length. So this is the length of the pets. This is how many times this iteration is going to run. And I++, we increment the value of I. So inside the for loop block, let's output the value of each element I inside the pets array. Let's hit Ctrl F5 to run our code. So we have dog, cat, tiger, and monkey. If you notice, the third element has been changed from fish to tiger. So let us try to do this with the for each loop. The for each loop is used exclusively to loop through elements in an array. So let's go ahead and use the for each loop to do the same thing we did here. So let's highlight this and hit Ctrl K, Ctrl C, comment that out so we know that we're using for each. For each string pet, and for each pet in pets array we want to log it to the console screen. Pet, that's it. Very simple, straightforward. Reads like English, reads like plain English. Let's hit Ctrl F5. Dog, cat, tiger, and monkey. The same thing, lesser lines of code. So this example can read like this: for each string element called pet as a single pet. In pets, print out the value of pet. If you compare the for loop and the for each loop, you will see that the for each method is easier to write, easier to read, does not require a counter like using the length property, and it is more readable. There are many array methods available. For example, the sort method, which sorts an array alphabetically or in an ascending order. For instance, let's try to sort the pets array. So we can say array.sort and then enter the particular array that we want to sort, and there you have it. It has been sorted. So let's print the value of, let's copy this for each loop to loop this array again to see sorted array. Ctrl F5 to run that. There you have it. This is the first loop, which is dog, cat, tiger, monkey. Now the order has changed. Cat, we now have cat, dog, monkey, tiger. It has been arranged in alphabetical order. So we can also sort numbers, not just strings. Let's add some space here so that we can know what we're doing. let's use this to add space before we do the sort integer array. So remember, we declared an integer array called my number. So let's try and sort. We called my num. Let's try and sort that integer array. So let's say my num. Sort it and try to loop through it for each int num in my num. So let's log that to the console. Hit Control F5 to run the program. There you go. We have 3, 4, 7, 10, 11 against the unordered. It was not in this order before we sorted the list. Here is the list. It started with 3, 7, 10, 4, 11. Now when we run this program, let's run it again. Control F5. You're going to see that it has been sorted according to from the smallest to the largest number, 3, 4, 7, 10, 11. So we use array.sort to sort an array. There are other useful array methods such as main, max, and sum. They can be found in the system.link namespace. So let's first of all bring in the system. Okay, it's already there. Using system.link namespace is already there. So if you don't have it, try to import them using system.link namespace. Let us find the maximum number in the my number array. But before that, let us add some space here. There's an empty right line. Let's call my num dot max. Let's hit Control F5 to run this program. So we have 11. What this means is the maximum number, the largest number on this array is 11. So let's try and find the smallest number with my num.main. So it's going to give us the smallest number in the array. So we have 3 as the smallest number in the array. Now let's do the sum. We have my num dot sum. These are some of the method that comes with an array. You can use these methods to get some certain information regarding the elements in an array, and then the sum of the total number or the total elements in an array is what the sum method returns. For my num array, it's returning 35. That means the sum of this number 10 plus 11 is 21, plus 7 is 28, plus 4 is 32, plus 3 is 35. All right, so if you're familiar with C#, you might have seen arrays created with the new keyword. Perhaps you have also seen arrays with a specified size as well. In C#, there are different ways to create an array. Let's check them out. Different ways to create an array in C#. So we have first string, square bracket, pads is equal to new string, square bracket 4. Here we created an array with 4 elements and add values later. Okay, creating an array of pets before, so let's say cars. This is an array of 4 elements. We just instantiated it and gave it a size. In this case, you're going to add the values of the array later. Now, the second type we are going to look at, second way to create an array we're going to look at is create an array of 3 elements and add values right away. Let's say we want to create an array of animals. What new string 3. Please do not forget to add square brackets after the data type of the array you're creating. It's very easy to omit this square brackets. That's what tells the compiler that you want to create an array variable. So do not forget that. Now let's add some values to this. Lion, we have snake, bird, then please add semicolon. All right, so let's create an array of 2 elements without specifying the size. String, square bracket, books, equal to, we're not going to specify the size. Let's go ahead and add new string, no size specified. Let's go ahead and add some values to that. We have hardcover book, hard copy book, and ebooks, ebook. So another way to create an array is to create an array of 2 elements omitting the new keyword and without specifying the size. So let's say string, never you omit the square brackets. Users equal to, omit the new keyword and do not specify the size. Let's say registered user, registered user, and visiting user, visiting user, visiting user, semicolon. It is up to you to choose which option you want to use. In this tutorial, we're going to be using the last option because it is faster and easier to read. However, you should know that if you declare an array and initialize it later, you have to use the new keyword. For instance, declare an array string phones, add values to an array phones equal to iPhone, Samsung, Techno. We're going to get an error. Look at these red marks here and there because you cannot assign the values to an already declared array without the new keyword. So when we add the new string, square brackets, the error disappears. This is how you add values to an already declared array. A method is a block of code which runs only when it is called. You can pass data, known as parameters, into a method. Methods are used to perform certain actions, and they are also known as functions. Why use methods? To reuse code, you define the code once and use it many times. C# provides some predefined methods which you already are familiar with, such as main. But you can also create your own methods to perform certain actions. Let's go ahead and create a method inside the program class. Static void my method. So a method is defined with the name of the method, in this case my method, followed by parentheses and opening and closing curly brackets, and where you put in the code to be executed. So my method is the name of the method we just created. Static here means that the method belongs to program class. You will learn more about objects and how to access methods through objects later in this tutorial. But then you will really appreciate and understand the meaning of the static modifier. Void means that this method does not have a return value. You will learn more about return values later in this section. In C#, it is good practice to start with an uppercase, like the M here in my method is an uppercase. It is good practice to start with an uppercase letter when naming methods. It makes the code easier to read because that's a convention. To call a method or to execute a method, write the method's name followed by 2 parentheses and a semicolon. For example, let's add some code to this method. Let's say this is my first method. Now let's call this method inside the main method. Let's call the method my method inside the main method. Let's say my method semicolon. That's all. We've just called the method we created. Now let's hit Ctrl F5 to run this program. And there you have it. This is my first method. So in this example, my method is used to print a text, which is the action when it is called. A method can be called multiple times. So let's do that. Let's try and duplicate this multiple times and call the method multiple times. It's allowed to call a method as much as you want. Let's hit Ctrl F5 to run this program. Now let's look at parameters and arguments. Information can be passed to methods as parameter. Parameters act as variables inside the method. They are specified after the method name inside the parentheses. You can add as many parameters as you want, just separate them with a comma. For instance, let's add some parameter to a method, my method. Let's add the parameter string, write the type, the data type of the parameter we want to add. This time around we are using string. We say name. This is the parameter we added to this method. So basically, let's try and use this parameter that we just added to this method. Let's say hello name. So now if you notice there's an error in the method call, and if you check the error message, it tells you there is no argument given that corresponds to the required formal parameter name of program.myMethod string. Okay, what this means is anytime we call a method that has some parameters, we have to add a value. We have to feed that parameter a value which we call argument. So for this case, we're going to add some names to it. I said Sunday. And note that the argument that you add in has to match the data type of the parameter in the method. So the parameter in the my method is a string. So we're adding a string argument to our method call. Kaine and Amaka. And the error disappears. So now let's run this program to see what we've got. Ctrl F5. Hello Tunde, hello Kaide, hello Amaka. So this example has a method that takes a string called name as parameter. When the method is called, we'll pass along a name which is used inside the method to print a greeting. When a parameter is passed to the method, it is called an argument. So from the example above, name is a parameter and Tunde, Kaine, and Amaka are all arguments. We also have what we call default parameter value. So you can also use the default parameter value by using the equal sign and adding the value, the default value inside the method, so that if we call the method without an argument, it uses the default value. Let's try and call the method without an argument. My method, this is going to call without an argument. Let's use this to add some space to differentiate what we already have. So let's hit Ctrl F5 to run our program and see what we've got. Hello Obina. So A parameter with a default value is often known as optional parameter. From this example, name is an optional parameter and Obina is the default value. Now let's look at multiple parameters. Let's remove this. Multiple parameters. You can have as many parameters as you like when creating a method. For instance, let's create another method. We're going to call this method static void my second. Let's use 2 for second method. And inside this, we're going to add 2 parameters, string name and int age, so that we can print something on the screen using the 2 parameters, name plus is plus age. Now let us call this method. Before we do that, let's use this to separate what we had before. So we are going to call our second method with some arguments. Let's say blessing comma is 5. Okay, this blessing has, okay, semicolon. Let's call another one, say my second method. I say Uche is 8. Let's hit Ctrl F5 to see the results. Okay, we see blessing is 5, Uche is 8. You have to know that when you are working with multiple parameters, the method call must have the same number of arguments as there are parameters, and the arguments must be passed in the same order. Just like the case of Uche, this is coming before the age. The name is coming before the age, or the arguments you're passing has to be equal with the parameters involved. If we remove that age, you'll notice that it's showing an error. So let's put that back. Now let's look at the return values of a method. The void keyword, this void that you're looking at here, the void here, and then the void here. The void keyword used in the examples that you see here indicate that the method should not return a value. If you want the method to return a value, you can use a data type such as int or double instead of void and use the return keyword inside the method. Let's create a new method to illustrate this. Let's return an int, and then this method, we're going to call it my third method. Okay, my third method. So inside this method, we are going to have an integer parameter. If you notice, we already seen a red wavy line on the method, which is telling us that not all code paths return a value, which means we need to have a return statement inside the method for this to compile. So we're going to go ahead and return. We're going to add 10 to whatever value of x the user enters. 10 plus x. So we're just going to return this value, which is an integer value. Now let's go ahead and write this to the console in our main method. Let's call my third method and give it a value of, say, 3. What do you think will happen? Let's hit Ctrl F5 and see. Your guess is as good as mine. It's going to be 13. So our method is working and is returning a value which is 13. All right, so let's try an example with multiple parameter. So here we're going to add y to x and return the value. So let's update this with 7. So if we run this, we are going to get 10. You already know. Good. So because this is doing a sum for us, another thing you need to know is you can also store the return value of the result of this in a variable. So let's create another variable. We'll call it int z equal to this method so that we can output the value of z to the console. Hit Ctrl F5 to run. There you have it. So this is recommended because it is easier to read and maintain. Named arguments. It is also possible to send arguments with the key value syntax. That way the order of the arguments does not matter. Here is what I mean by that. We have what we call named arguments arguments, and here is the syntax key value. So now let's create the fourth method to illustrate what we mean by named arguments. Static void. This our fourth method is going to have 3 parameters. We're going to have string play1, string play2, and finally string player3. So we are going to log an information with one of the parameters. So we're going to say the fastest player is player 3. Now, how do we use the named arguments? If we want to call this method with the named argument, here's what's going to happen. We're going to use this key value syntax to impute our arguments. Named arguments are especially useful when you have multiple parameters with default value and you only want to specify one of them when you call it. That way, the order of arguments does not matter. Player 3 is Joseph. Let's say player 1 is Adam. Lastly, player 2 is Jumbo. Hit Ctrl F5 and run this program. We are going to get the fastest player is Joseph, because Joseph is the third player, is player 3. So it doesn't really matter where the position of the parameter and when we were declaring our method. So player 3 is in the last parameter, but here we made it the first parameter because we're using named argument. And the named arguments are especially useful when you have multiple parameters with default values and you only want to specify one of them when you call it. So let's try to illustrate that here. Let's copy this method in order to save time. So we are going to say fifth method player 1 is equal to, we give it a name, let's say player 2 is equal to Joshua, and then player 3 is equal to Adam. The fastest player is player 3. We can call this method, okay, before call this method, let's give some space. Using this, we can call our method. We can enter one argument, and here we are going to use the parameter value player 3. Put your semicolon, and then you hit Ctrl F5. The fastest player is Adam. Player 1 is Joseph. Player 3 is Adam. With method overloading, multiple methods can have the same name with different parameters. Let's try that out. Let's create method overload with the methods we have here. So my method has a string parameter. Let's create another my method with a different parameter. Control C. Let's copy that and paste. We've created another my method. So basically, let's change the parameter here. Let's change the parameter here to another type int. Did you notice something? The error that was shown before has disappeared. We're just going to call this age, and then let's create another one. Let's convert this my to method to my method, it will still work comfortably because we are using two parameters. The parameters are not the same with the one we have here and the first one. And same thing we apply for this method 3. You can decide to remove this 3 and it will work perfectly well. And same thing can happen for method 4 because it has different parameters. The only place that it will not work is this method 5 because method 5 and method 4 has almost same parameters. It has string parameters and they are 3 in number. So let's, edit our code to match what we have. Remove the numbers and let us run this code and see if it's going to come out very well. Hit Ctrl F5. did you notice that everything is still working perfectly as it was working before? So why do we use method overloading? Instead of defining two methods that should do the same thing, it is better to overload one. So in this example, we first of all defined different methods for each example we showed, but because we can overload this method, we decided to use the same methods for all of these examples, being that their parameters are either of different types or they have different number of parameters. So these are the two key things that you need to put into consideration. If you have parameters of different data types and or you have different number of parameters, you can actually overload the method and use the same name instead of writing different methods. So multiple methods can have the same name as long as the number and or type of parameters are different. Congratulations for making it this far in this C# fundamentals tutorial. Big ups to you. The next sections of this video is supposed to be about object-oriented programming concepts and some intermediate concepts of C# programming. So before we get there, let's create something fun and interactive with the concepts we have learned already. Let's create a number guessing game. Are you excited? Alright, to get started, let's go to C# Basic Solutions and right click on there, then add new project. Now select console application, select next, continue. The name of our project is guessing game. Okay, hit create to create our program. We will create a game where the player will try to guess a random number. Fundamental programming concepts will be covered as we build this C# console application. The framework of our game will have just one class, the program class. A method, game, will hold the statements that will run the game. Two variables will be used, one to track the number the player enters and one that will be the target number. So let's go ahead and add these variables and method to our program class. Let's add the two variables first. Just above the main method, let's add our variable static int guess, static int target. So let's go ahead and add our game method. It's also going to be static method, static void returns nothing, game. Statements. Now the statements that runs our game, that runs the game, we're written here. Now let's call our game method inside the main method. Remove this line of code and call our game method. Now that we have a starting point, let's add some statements to the game method. First, we should write out an instruction to our player. We can make it simple or fanciful. A simple statement would be something along the lines of enter a number. Okay, prompt the user. It's good practice to use comments to decorate your code so the user would know what you're doing. So let's go ahead and prompt the user to enter a number. Enter a number. A more creative example would be, I see a number coming towards me from the depth of my mind. Can you guess what it is? No, we're not going to use that. Okay, you can as well write an instruction for the player in whichever style you like. Now the next thing we're going to do is read user inputs. So we're going to do that with console.readline. You already know about that. Console.readline. And then we are going to assign the value of console.readline to our guess variable. So guess will now be equal to console.readline. It's showing us an error. So we need to fix this error, and the reason for this error is because our variable is an integer type and the readline method reads input as a string. To compare what the player types to a number, we would need to convert it to a numeric value. There are several ways to convert data. In this example, we will use convert.toInt. We would convert player input from a string to a number in 2 steps. So let's go ahead and use convert dot to int 32 and wrap our input inside. Our input has been converted to an integer. Now the next thing we're going to do is to return a feedback to the user, and the feedback is going to tell the user whether or not they guessed the right answer. Let's return a feedback to the user. The feedback is you guessed. Guess plus and the number I was thinking about. The number I was thinking of was target. And that's our game. Simple, right? Very, very simple. Now we have a very basic game. So to test our code, let's give target a value. Let's give target a value of 7. Go to guessing game class, right click the guessing game class and set as startup project. Now let's hit Ctrl+5 to run our program. Enter a number. Let's say 10. You guessed 10. Okay, the number I was thinking of was 7. There's an error here. We need to correct that typo. I was thinking of was 7. So as you can see, our game is running smoothly, but the game tells the player what they entered and what the target number was. It doesn't congratulate them if they got it right or give a different message if the numbers don't match. We need a conditional statement so that separate messages can be shown for each situation. So let's go ahead and under the feedback, we are going to create an if statement that checks if guess is equal to target. Then we have to say something in the line of congratulations, you guessed let's enter the guess plus and the number I was thinking of was, let's add a target. Let's put some full stop. So now what happens if the number the user guesses was wrong? Let's add an if statement to handle that. Let's take this away and too bad, you guessed and the number I was thinking of was, let's enter the target number plus full stop. So now the conditional statement shows a different message if there's a match and if there's no match. So let's run this code to see the results. Enter number 7. Congratulations, you guessed 7 and the number I was thinking of was 7. Did you see that? It's running perfectly because I guessed it correctly. But then again, we currently have a hard-coded number as the target. After the first time someone plays, they know the answer, they will know the answer, and playing again wouldn't be much fun. We can use .NET Framework's random class to make it less predictable. At the top of the game class, let's create an instance of random and add a keyword static to it. Static random. Let's call it random. Let's call it random number, which is equal to new random. Okay, good. Don't worry if you don't understand what an instance of a class is. We'll look at classes and objects in the object-oriented programming section, which is coming up next. Now, inside our game method, let us call the next method of the random object, passing an integer representing the range of numbers it should pull a random number from. Generate random number. So let's remove this value for 7 for target. Let's now create a random number for target. Target is equal to rand number dot next. We want to generate random number from 1 to 10. So we're going to add +1. Usually in a guessing game, we ask for a number in a range that starts with 1. For example, guess a number between 1 and 10. Without the +1, the range of numbers in the above line of code would be 0 to 9. Adding +1, the range is now 1 to 10. The next method is overloaded, so you could alternatively pass in 2 values that will return a range between them. For example, to return values from 1 through 10, you would use rand number dot next. From 1 through 10, and that's it. So it's either you use this method or you use this method. You already know what method overloading is, so there's no need to explain more. Let's now let the player know what the range of numbers are by updating the instructions that are written into the console window. So let's update the instructions to guess what number between 1 and 10 I am thinking of. Okay, let's check to make sure that the player is entering the type of information we are asking for. Right now, if the player accidentally enters a letter instead of a number, there'll be an error. Let's try that and see. Control F5. Guess what number between 1 and 10 I am thinking of. Okay, let's just say I enter W. On handle deception, an error has been generated. So let's close our program and handle this error programmatically. So we're going to handle this error using try pass method. With try pass, we can check to see if guess is a numeric value, that is if the user input is a numeric value. Now to do that, we need to add another variable to the program class, and this variable, we're going to call this variable input. It's going to be a static string input. Let's give it some empty value. So now If the value of the string is numeric, we will save it as guess. Okay, right now we are going to create an if statement. We're going to create an if statement that is going to handle the kind of input the user is entering. Remove this conversion that is happening here so that we'll be able to take the user input as a string. So when we do that, we are going to create an if statement. So we'll have int tryPass. TryPass method takes in two arguments. The first being the input we're trying to convert. So we will now have an out keyword, and then the variable we want to out the converted input to, or the converted value to. So basically what happens here is when the user enters an input, we will take this input and check if it is convertible. If it's a numeric input the user entered with a number, this tryPass will convert that number to an integer and save it in our guess variable. But if it's not, then it's going to return false. If it's a number, it returns true. Then we're going to copy this code and place it inside the first block of the if statement. If the user input is a number, it will be converted to an integer, can be outed or saved in guess. Now we'll check if guess is equal to the target that's been generated by the random number generator. If it's correct or if it's true, we'll print a message to congratulate the player. But if it's false, we'll also print a message to let the player know. So our code is almost done. So what if the input the user entered was not a number? Let us handle that here. We'll say else. We'll now print a message to tell the user to enter a number. Please enter a number. Please enter a number. We're also going to print another message to tell the user to press enter to continue. And let's use console.readline to wait for the user's input. And then we are going to do what we call a recursive callback to our method. So what we did was we asked the user to make sure they're entering a number and to try again. We did a recursive call to gain, which will start the game code again so they can give it another try. It's possible to call a method inside itself. Like we call this game method inside the main method, which is outside the method game that we defined. It is also possible to call the method inside itself. What we call that is recursive call. Here is our game. Let me add a line break. You can use this to add a line break. All right, so let's hit Ctrl F5 to run our game. Guess what number between 1 and 10 I am thinking of. Let's start by making a mistake. Let's say I enter a letter instead of a number. Hit enter. Please enter a number. Press enter to continue. I press enter. Guess what number between 1 and 10 I am thinking of. Okay, let me say I guess 9. Too bad, you guessed 9 and the number I was thinking of was 10. Let's hit enter again. It has gone. Now, to get this game to continue running until we exit the console window, we will have to wrap it around a while loop. So say while true, the game should continue running. So let's copy this method. Let's cut the method and paste it inside the while loop. What this is going to do is it will keep the game running and running and running until you are tired of running the game and close the console window. Let's try that again. Control F5 to run. See what we've got. Guess what number between 1 and 10 I am thinking of. Okay, let me guess 5. Too bad you guessed 5 and the number I was thinking of was 10. Wow. Enter again. Guess what number between 1 and 10 I'm thinking of. Let me say 9. Too bad you guessed 9. The number I was thinking of was 4. Let's go again. Okay. Too bad you guessed. I got another one. Too bad. If you notice something, our game keeps on running and running and running and running. Congratulations, you guessed 8, and the number I was thinking of was 8. And oh my god, I was able to guess a particular number. Man, I would have been so shocked. Here. In software development, we have different approach or paradigms developers use to design softwares. As a result, we have the procedural or functional programming paradigm and the OOP, which stands for object-oriented programming style. Procedural programming is about writing procedures or methods that perform operations on the data, while object-oriented programming is about creating objects that contain both data and methods. Object-oriented programming has several advantages over procedural programming. Object-oriented programming is faster and easier to execute. Object-oriented programming provides a clear structure for the programs. Object-oriented programming helps to keep the C# code dry. Dry here being an acronym for don't repeat yourself. It makes the code easier to maintain, modify, and debug. Object-oriented programming makes it possible to create full reusable applications with less code and shorter development time. The don't repeat yourself DRY principle is about reducing the repetition of code. You should extract out the codes that are more common for the application and place them at a single place and reuse them instead of repeating them. Classes and objects are the two main aspects of object-oriented programming. Look at the following illustration to see the difference between classes and objects. Here, class is a fruit and objects will have apple, will have banana, will have mango. These are objects. So another example is car is a class, and then objects of this class is Volvo, Audi, Toyota. So a class is a template for objects, and an object is an instance of a class. When the individual objects are created, they inherit all the variables and methods from the class. You'll learn much about classes and objects later in this tutorial. Learn from the previous section that C# is an object-oriented programming language. Everything in C# is associated with classes and objects, along with its attributes and methods. For example, in real life, a car is an object. The car has attributes such as weight, color, and methods such as drive and brake. A class is like an object constructor or a blueprint for creating objects. How to create a class? To create a class in C#, we use the class keyword. Let's create a class named car with a variable color. Just on top of the class program, let's use the keyword class and create a class called car. And then we're going to put a variable inside the class. And what color we're going to give to this car is red. When a variable is declared directly in a class, it is often referred to as a field or attribute. It is not required, but it is a good practice to start with an uppercase first letter when naming classes. Also, it is common that the name of the C# file and the class matches, as it makes our code organized. However, it is not required like in Java. Don't worry, you will understand these furthermore. Let's create an object of this class that we just created. So to create an object of car, specify the class name followed by the object name. Let's create the objects inside our main. So to create an object of car, specify the class name, car, followed by the object's name. This time I'm gonna say my obj and use the new keyword and before car. Now we've been able to create an object of the car class, and the name of the object is my object. So this object we created, this my object, is an instance of the class car. So we can use this object to access the value of the variable inside the car class. So let's print the color of the car to the console. Say my object dot color. Did you notice something? It's not showing. We couldn't access this, so let's make this public so we can access its property. Now as you can see, the color, it's no more showing error. It's now compiling. Let's hit Ctrl F5 to run the program. So what we've got, red. Okay, we're able to print the color of a car. And one more thing you need to note is that we use the dot syntax to access variables or fields inside a class. We also use the dot syntax to access the methods inside a class. In fact, every member of the class could be accessed using the dot syntax. The same way we use the dot syntax here to access the writeLine method of the console class. Don't worry, you're going to learn more about fields in this video. You can create multiple objects of one class. For example, let's create two objects of car. Created the first object, my object 1. Let's create another one, car my obj 2 equal to new car. So we can also add one here, print the color of the second object. Of course, it has to be the same color. Ctrl F5, see we've printed red. You can also create an object of a class and access it in another class. This is often used for better organization of classes. One class has all the fields and methods, while the other class holds the main method code to be executed. Did you notice the public keyword that I used here? It is called an access modifier, which specifies the color variable field of car is accessible for other classes as well, such as the program class. So the time we wanted to access the color property before we added this public keyword, it wasn't accessible by this program class. Immediately we added public keyword, we were able to access this. Don't worry, you will learn much about access modifiers and classes and objects soon in this tutorial. What are class members? Fields and methods inside classes are referred as class members. Example, let's create a class called car. Class car. Now let's add some comments to this. This is class and let's add some class members. Say for instance the color, let's give us a value, say red. Color of our car is red, and let's add some attributes to the car. Maximum speed of this car is 200. This is a field, or you can call it attribute. Call it field in C#. And now let's add some method to this class. Public void your car is driving. So this is method. All right, so guys, this is our class car, and as our comments suggest, we have the class. This is the class, and then this is our class members. All of these things are class members. Now these are fields, and this is a method in a class. We've learned in the previous section that the variables inside a class are called fields, and that you can access them by creating an object of the class. Where we created my obj class, and then we use the dot syntax to access the fields of a class. Now we're going to go ahead and create the output of the car class with the name my obj. You already know how we'll do this. You write the name of the class first, then followed by the name of your object. I'm going to use my obj, then equal to, use the new keyword car. So this right here is the instance of the class car. So we are going to print the value of the field's color and maximum speed. Print some things to the console. Let's say my object dot. If you notice, we can't find our fields. We can only find our method. Can you guess why we couldn't access our field? What I wanted to print out is the color, and we couldn't find it. The access modifiers by default, if you don't add this public, is private. If the access modifier is private, you can access the fields or the methods from another class. So we just have to add public keywords there so we can access the fields here. So I want to access the color field, and there you have it. Same goes with the maximum speed attribute. Let's hit Ctrl F5 to run the program and see what we've got. Red 200. You can also leave the fields blank and modify them when creating the object. For instance, instead of giving values to the fields, we clean the values that we give to the field and leave them blank like this. We can give values to the field when we are creating our object. Say my object dot color equal to blue. My object dot maximum speed equal to 200, and this is still valid. If you hit Ctrl F5, run your program, see how it goes, and see what. This is essentially useful when creating multiple objects of one class. For instance, let's add another field to our car class. Say public and year. This is a field. Let us comment this out and create multiple cars. Toyota. Go to new car. Let's add another field to our class. Public string model. This is a field. So Toyota dot model is equal to Corolla. That is the model. Car is going to be Toyota. Color will be equal to silver. Toyota dot year will be equal to 2014, and Toyota dot maximum speed is equal to, say, 300. So now let's create another instance of the car class. Car, say, Lexus. Got a new car. Car Lexus. Let's add some attributes to our car. Let's give it model will be equal to ES 330 Lexus dirt. Okay, let's give it a color be equal to black. Lexus max speed will be equal to 250, and then the year will be, this is the year, equal to 2010. So now let's print out the values of the two cars. Let's print out the model of our cars. Let's say Toyota model. Lexus, the model. Hit Control F5. See, we have Corolla, we have ES330. These are the models. You can actually use the dot syntax to access any of this field, so print any of the fields of interest. So what we did here is we added values to match the fields of each object of the car class. Object methods. You learn from the C# methods section that methods are used to perform certain actions. Methods normally and they define how an object of a class behaves. Just like with fields, you can access methods with a dot syntax. However, note that the method must be public. Remember that we use the name of the method followed by two parentheses and a semicolon to execute the method. For instance, let us call the drive method of our car. Which of them are we going to drive? We have two cars. Which of the cars are we going to drive? Let's drive Lexus. So Lexus dot drive. We just called the drive method of the car class. Let's hit Ctrl F5 to run. Your car is driving. I mean, it's running. So why did we declare the method as public? If you notice, we declared this method as public. We declare this method as public and not static like in the examples from the C# methods chapter. The reason is simple. A static method can be accessed without creating an object of the class. Remember from the last section that we can use multiple classes for better organization. One for fields and methods and another for execution. This is recommended. The public keyword is called an access modifier, which specifies that the fields of car are accessible for other classes as well, such as program class. You will learn more about access modifiers later on in this video. You'll also learn more about other class members such as constructors and properties. A constructor is a special method that is used to initialize objects. The advantage of a constructor is that it is called when an object of a class is created. It can be used to set initial values for fields. Let's create a class. Class car. Let us add a field to it. Let's call this field model. Class. Let's create a class constructor for this class. Public car model is equal to Camry. Sets the initial value for model. This is a constructor. For the car class. So now let's try and create an object of our car class, car Toyota. Remember to always use the new keyword when you are trying to create an instance of a class or create an object of a class. creates an object of the car class. So now let us try and let's print the value of the model. Type Toyota.model. Hit Ctrl F5. Camry. This outputs the initial value of the model. Prints the value of the model. Notice that the constructor name matches the class name and it cannot have a return type like void or int. Also note that the constructor is called when the object is created. All classes have constructors by default. If you do not create a class constructor yourself, C# creates one for you. However, you are not able to set initial values for fields. Constructors save time. Constructors can also take parameters, which is used to initialize fields. Let's create an example. Alright, let's refactor our constructor so that it can take in parameters. Our parameter is going to be string model name, so that model will now be equal to model name. Going back to our objects in the main, you realize that we're already seeing an error. This is telling us that we need to put in an argument that matches the parameter in our constructors, which is model name, and it's a string. We can say Corolla or Camry, whichever one. The Corolla. Ctrl F5. Corolla. You can have as many parameters as you want. I have model, I have public string, color, public int, year. Let's add these fields as parameters to our constructor. Color and year. So that when we try to create our object, it will require us to enter these values into the constructor as arguments. So gray, color is gray, and the year is, say, 2013. Let's try and print some of these values. Toyota plus Toyota dot color plus space plus Toyota dot here, add plus here. Toyota plus space. We've not assigned these values to, we've not assigned the values from our constructor to our class fields. Let's do that. Color is equal to color. If you notice something, it looks as if we are calling the same things. So we can say this dot color, this dot year is equal to year. Now this keyword that I used here refers to the class itself. So this represents the object or the instance of this class. So this dot color will now assign the color that's coming from the constructor to it. This year, we assign the color that's coming from the constructor to the year. When we hit Ctrl F5 to run our program, you will notice that it's showing gray 2013 Corolla. It's working perfectly. Just like other methods, constructors can be overloaded by using different numbers of parameters. Constructors save time. When you consider the example from the previous sections, you will notice that constructors are very useful as they help reducing the amount of code. With that constructor, we had to use the dot syntax to enter the values of each field in the previous section. So constructors has helped us to enter everything at the same time while we are trying to instantiate our class. We enter the arguments directly into the constructor without having to use any dot syntax and type long-winded code. By now, you're quite familiar with the public keyword that appears in many of our examples. The public keyword is an access modifier, which is used to set the access level or visibility for classes, fields, methods, and properties. C# has the following access modifiers. Modifier description. We have the public. The code is accessible for all classes. Private. The code is only accessible within the same class. Protected. The code is accessible within the same class or any class that is inherited from that class. You will learn more about inheritance later in this tutorial. Internal. The code is only accessible within its own assembly, but not from another assembly. You will learn more about this in a later section. There's also two combinations, protected internal and private protected. But now let's focus on public and private modifiers. Private modifier, if you declare a field with a private access modifier, it can only be accessed within the same class. Let's create a class. And make our field private. String model is equal to Volvo. Instead of having this main method inside the program class, let's cut this main method and put it inside this class. Let's create an object of our class. Now let's print the value of the model, my object model. Now hit Ctrl F5 to run and see what you've got. Volvo. Now if you want to access it outside the class, an error will occur. Let's try to access it outside the car class. Let's move the main method into the program class and try to access model. There's already an error showing. Hit Ctrl F5 to run this program. There were build errors. Would you like to continue and run the last successful build? So there were build errors. It could not compile. The problem is that the car.model is inaccessible due to its protection level. So if you declare a field with a public access modifier, it is accessible for all classes. Now let's go ahead and turn this private to public. The error has disappeared. So if we hit Ctrl F5, our program runs without an error. So why access modifiers? We use access modifiers to control the visibility of class members, the security level of each individual class and class member. We use access modifiers to achieve encapsulation. Encapsulation is the process of making sure that sensitive data is hidden from users. This is done by declaring fields as private. You'll learn more about this in the next section. By default, all members of a class are private. So if you don't specify an access modifier, it is private by default. What this means is if I remove this access modifier here, this automatically becomes private and it will not be accessed by our object in another class program. Before we start to explain properties, you should have a basic understanding of encapsulation. The meaning of encapsulation is to make sure that sensitive data is hidden from users. To achieve this, you must first of all declare fields and variables as private, and then you provide a public get and set methods through properties to access and update the value of a private field. You learned from the previous section that private variables can only be accessed within the same class. An outside class has no access to it. However, sometimes we need to access them and it can be done with properties. A property is like a combination of a variable and a method, and it has two methods, a get and a set method. For example, let's create a field in our program class, call it private string name. This is a field. Now let's create a property, public string distinguish the name of your fields and properties. Try and use capitalization for your property names. Like I said before, a property is a combination of a field. It's like a combination of a field and method. So inside the get method, we're going to say return name, and this is a get method. So let's create the set method. So in the set method, we are going to assign a value to the name field. Set method. So let me try and explain this for you. The name property is associated with the name field. It is a good practice to use the same name for both the property and the private field, but with an uppercase letter for the property. The get method returns the value of the variable name. Then the set method assigns a value to the name variable. The value keyword represents the value we assign to the property. If you don't fully understand it, let's look at an example. Let us take our class members and put it inside another class. So this is a person class, and we want to access the person class from the program class main method. So we're going to create an instance of the person class. Say my object equal to new person. My object dot name. Notice that we are only accessing the property. We're accessing the property and we can assign a value to it. Say obina. We can also get the name using the same property. My obj dot name. And hit Ctrl F5 to run your program. There you go, obina. So basically we're able to use the property get and set value to set the value of our private field name and to use the same property to access the value. And what we did there was encapsulation. C# also provides a way to use shorthand or what we call automatic properties, where you do not have to define the field for the property and you only have to write get and set inside the property. Now let's change our person code to the shorthand property. Let's change it to a shorthand property, or you can call it automatic property. Get set. That's all you need to do. C# understands what this means. So there you go. A property. If you hit Ctrl F5, with everything still being the same, the program will still run. Maybe now. So this is shorthand. You don't need to specify the values. So why do we need encapsulation? It helps us to better control the class members, to reduce the possibility of yourself or others to mess up the code. Fields can be made read only if you only use the get method, or write only if you only use the set method. The programmer can change one part of the code without affecting other parts, and increased security of data is achieved with encapsulation. In C#, it is possible to inherit fields and methods from one class to another. We group the inheritance concept into two categories: derived class, which is the child class, the class that inherits from another class; the base class, which is the parent class, the class being inherited from. To inherit a class, we use the colon symbol. Let's see an example. Now let's create a class called vehicle. Let's add some fields to it. Brand. Let's give it a value. Let's say a brand is Lexus. So this is vehicle field. Let's create a method called public void. vehicle. Let's say engine starting. Now let's create another class, and this class is going to be the car class, which we inherit from the vehicle class. So this class is parent class, or I'll call it the base class. And this class is the child class. Or derived class, because the core class is inheriting the members of the vehicle class. So the only thing I'm going to add here is public model field. So the model name is equal to RX 350 as the model of our car. All right, now so let's see how inheritance works. Let's create the car object. Car, my car, to go to new car, and give it a comment. Create my car object. So now let's call the start method of the vehicle class on our car object. My car dot start. Remember, this method was from the vehicle class. The car class does not have this method, but we're able to call it on the car objects because of inheritance. Call the start method. Start method from vehicle class. On my car. And finally, let's display the model, the brand. The car class does not have brand, it has model name, but we're able to access the brand from the vehicle class which the car class inherited. Now hit Ctrl F5 to run the program. Engine starting Lexus, that's the brand. So, and when to use inheritance. It is useful for code reusability, reuse fields and methods of an existing class when you create a new class. We're also going to look at polymorphism, which uses inherited methods to perform different tasks in the next section. Before that, let's look at the sealed keyword. If you don't want other classes to inherit from a class, you use the sealed keyword. If you try to access a sealed class, C# will generate an error. Let's say, for instance, if we decide to seal the vehicle class, it says sealed. Now that we have sealed the vehicle class, it's not possible to inherit from the vehicle class anymore. So cannot derive from sealed type. That is the error you get when you're trying to inherit from a sealed class. Polymorphism simply means many forms, and it occurs when we have many classes that are related to each other by inheritance. Like we specified in the previous section, inheritance lets us inherit fields and methods from another class. Polymorphism uses those methods to perform different tasks. This allows us to perform a single action in different ways. For example, think of a basic class called animal. Let's create the class animal. This is going to be our base class. Let's create a method inside. Animal sound, which of course every animal makes a sound, so we are going to say the animal makes a sound. So the derived classes of animal could be pigs, cats, dogs, birds, and they also have their own implementation of an animal sound. The pig oinks and the cat meows. The dog barks. So let's try and create other derived classes of the animal class. Let's say pig. Pig derives from animal. So pig is a derived class. Okay, call it a child class. Let's implement animal sound. Public void animal sound. The pig says wee wee. Let's create the dog class. Dog class inherits from the animal class. Let's try and implement the animal sound. And say the dog says bow wow. Now we can create a pig and dog objects and call the animal sound method on both of them. First of all, let's create an animal. My animal equal to new animal. Creates an animal. Creates my animal objects. Let's create another animal. Pig equal to new pig. New pig. This creates a pig object. Animal dog equal to new dog. This creates a dog object. Now let's call the animal sound on the three animal objects that we created. My animal dot animal sound. We can say pig dot animal sound. Animal sound. Dog dot animal sound. Hit Ctrl F5. What do you think you're going to get? The animal makes a sound. The animal makes a sound. The animal makes a sound. Gotcha. See, the output from this example was probably not what you expected. That is because the base class method overrides the derived class method when they share the same name. However, C# provides an option to override the base class method by adding the virtual keyword to the method inside the base class and by using the override keyword for each derived class method. Now let's update our code, the virtual and override keywords. Now go to the base class. Before the void, make it virtual. Let's go to the P class, use override. use the override keyword here, and also use the override keyword here. And that's all you need to do. Hit Ctrl F5 again to run your program. The animal makes a sound. The pig says wee wee. The dog says bow wow. Would now work separately. Use inheritance and polymorphism. It is useful for code reusability. Reuse fields and methods of an existing class when you create a new class. Data abstraction is the process of hiding certain details and showing only essential information to the user. Abstraction can be achieved with either abstract classes or interfaces, which you will learn more in the next section of this video. The abstract keyword is used for classes and methods. Abstract class is a restricted class that cannot be used to create objects. To access it, it must be inherited from another class. Abstract method can only be used in an abstract class, and it does not have a body. The body is provided by the derived class, the class it's inherited from. An abstract class can have both abstracts and regular methods. For instance, let's create an abstract class. Abstract class called animal. Let's give it an abstract method, public abstract void animal sound, animal sound, animal sound, semicolon. Let's give it another method, public void sleep. Okay, now let's try and create an object of this class and see what we're gonna get. Animal. Go to new animal. You're getting an error because it cannot create an instance of abstract type animal. So it's not possible to create an instance of an abstract class. So to access the abstract class, it must be inherited from another class. Let's convert the animal class we use in the polymorphism section to an abstract class. Also remember that in the inheritance section, we use the colon symbol to inherit from a class, and that we use the override keyword to override the base class method. Let us comment our classes. Abstract class. This is an abstract method. This is a regular method. Let's create another class. Going to be class pig derived from animal. So this is a derived class because it's was inherited from animal class. If you notice, already we are seeing a which says pig does not implement inherited abstract member animal sound. So there's an abstract class that needs to be inherited. So to do that, we are going to say public override void animal sound. So we enter our implementation of the pig sound. The pig says wee wee. So now let's try and create an object of pig class. So this is a new pig object, pig equal to new pig. create pig object. So pig dot animal sound. I'm trying to call abstract method. Let's call the regular method pig sleep. Call the regular method. Let's hit Ctrl F5 to run our program. The pig says z. So as you can see, we're able to create an abstract class called animal. We created an abstract method inside the animal class and a regular method inside the animal class. And the next thing we did was created a pig class, which was a derived class, a child class of the animal class. So we now had to implement the animal sound abstract method inside the pig class. Remember, we used the override keyword to make us able to implement the abstract method. So we can as well, instead of using virtual here keyword, just like we did in the inheritance section, we use virtual keyword on the method we want to override and use the override keyword in its derived method. So basically here, the abstract keyword makes this method abstract, and then we use the override keyword here to override the abstractness of that class. Then we were able to create the object of the pig class, because we cannot create an object of an abstract class. So now we were able to call the abstract method, and we're also able to call the regular method of the animal class that was inherited by the pig class. We use abstract classes and methods to achieve security. We use it to hide certain details and only show the important details of an object. Also know that abstraction can also be achieved with interfaces, which we are going to learn next. Another way to achieve abstraction in C# is with interfaces. An interface is a completely abstract class which can only contain abstract methods and properties with empty bodies. For example, let's go ahead and create an interface. We use the interface keyword to create an interface. We're going to call it animal. Let's give it a method. Animal sound interface method. The interface method does not have a body. Let's create another method, run. This is also an interface method. Interface methods do not have body. It is considered good practice to start with a letter I at the beginning of an interface, as it makes it easier for yourself and others to remember that it is an interface and not a class. By default, members of an interface are abstract and public. Interfaces can contain properties and methods, but not fields. An interface does not contain a field, so you don't put a field to it. So therefore, let's add that capital letter I on our interface to make it look conventionally like an interface. To access the interface method, the interface must be implemented, something like inherited, but by another class. To implement an interface, you use the colon symbol, just like we did in the inheritance class. The body of the interface method is provided by the implement class. You don't have to use the override keyword when implementing an interface method. So let's try and implement this interface. The interface with the pig class. So we're going to have iAnimal. So this wavy line here is showing us an error that the pig does not implement interface member iAnimal.animalSound, does not implement interface member iAnimal.run. So let's go ahead and implement them. Let's say public void animal sound. So we are going to give the pig a sound. The pig says, you already know, we. So let's also try and implement the run method. Public void run. It is running. As you can see, there are no more errors on our code because we've been able to implement all the abstract methods that came with the iAnimal interface. So let's go ahead and create an object. P class implements the iAnimal interface. Notice that we didn't have to use the override keyword here to be able to implement the methods of an interface. So let's go ahead and create the object of the big class. Pig is equal to new pig right pig object pig dot animal sound. Let's call the animal sound method of the pig class. All right, so let's go ahead and hit Ctrl F5 to run our program. See what we've got. The pig says we. Like abstract classes, interfaces cannot be used to create objects. It is not possible to create an iAnimal object in the program class. Interface methods do not have a body. The body is provided by the class that implements the interface. On implementation of an interface, you must override all of its methods, and you do not need the override keyword to do that. Interfaces can contain objects and methods, but not fields and variables. Interface members are by default abstract and public. An interface cannot contain a constructor, as it cannot be used to create objects. Why and when do we need to use interfaces? Number one is to achieve security. We use it to hide certain details and only show the important details of an object. Number two, C# does not support multiple inheritance. A class can only inherit from one base class. However, it can be achieved with interfaces because the class can implement multiple interfaces. To implement multiple interfaces, separate them with a comma. An enum is a special class that represents a group of constants. Constants being unchangeable and read-only variables. To create an enum, use the enum keyword instead of class or interface and separate the enum items with a comma. For example, let's create an enum. Enum level, low, medium, and high. We've created the enum code level so we can access enum items with the syntax. So let's try and access our enum. Let's create a variable called my level and give it a value of level dot medium. Let's put it out on the console. My level. Hit Ctrl F5 to run our program. The level is medium. Enum is short for enumerations, which means specifically listed. You can also have an enum inside a class. Let's try and create an enum inside a class. Let's copy this enum that is standing outside the class. By sitting outside the class, copy it out and put it in our program class. There you go. It will still work perfectly. It's Ctrl F5. It will work perfectly. By default, the first item of an enum has the value 0. The second has the value 1, and so on and so forth. To get the integer value from an item, you must explicitly convert the item to an int. Let's say, for instance, I want to get the integer value of this. I would say, okay, int, and convert this explicitly. You already know this. This is what we call casting to an int. And there you go. We've been able to convert this to an int. Let's hit Ctrl F5 to see the integer value of this. It's 1 because it's in the index position of 1. The low is 0, medium is 1, high is 3. You can also assign your own enum values, and the next items will update the number accordingly. Let's take, for instance, we can assign medium to be equal to 5 instead of 1. When we hit Ctrl F5, we're going to get 5. Okay, let's say we want to get our high will now be 6. See, the next item is updated accordingly, but then our low will be 0. We can use enums in a switch statement. Enums are often used in switch statements to check for corresponding values. So let's create a switch here. Comment this out. So let's create another variable, call it level, and give it a value, level dot high. So let's switch level, say for case level dot low, let's say level break case level dot medium. Medium level, call this medium level. Break case level dot high, say high level. Break, and that will be it. So if we hit Ctrl F5, what are we going to get? You already guessed it. We're going to get high level, because that was the value of this variable that we imputed in our switch statement. So why and when to use enums? We use enums when you have values that you know aren't going to change, like months, days of the week, colors, deck of cards, gameplay levels, some constant values that you know that they're not going to change. The file class from the system.io namespace allows us to work with files. The file class has many useful methods for creating and getting information about files. So we have the append text, which appends text at the end of an existing file, copy, which copies a file, create, which creates or overrides a file, deletes, which deletes a file, exists, tells whether the file exists, read or text, reads the contents of a file, replaces contents of a file with the contents of another file, write or text, creates a new file and writes the contents to it. If the file already exists, it will be overwritten. For a full list of methods, go to Microsoft.NET file class reference. Now let's look at an example where we will use the write or text method to create a file name and write some content to it. Then we use the read or text method to read the contents of the file. First of all, let's import the system.io namespace. Remove this string write text. Go to hello, I created this file from C# I created this file with C#. File dot write all text. Write all text method creates a new file and writes the specified string to the file and then closes the file. If the target file already exists, it is overwritten. Here we're going to enter the path to find our file. Let's give it a name, file name .txt, and comma. This is the text that we want to write. Enter a write variable. Now we're going to try and read the content of our text file. Read text equal to file dot read all text. Read all text method. We're going to provide a file path, just file name dot txt. Then we're going to output the value of our file that we read to the console. So let's hit Ctrl F5 to run our program. Hello, I created this file with C#. Alright, so to locate the file that you just created, go to your files project, right click and go to open folder and file explorer. And if you open, this is where all your files, your project files are. Go to bin, go to debug, go to .NET 5.0. Then this is the text file that you just created, file name.txt. If you open it, you're going to say, hello, I created this file with C#. So close the folder. That is where your file lives. When executing C# code, different errors can occur. Coding errors made by the programmer, errors due to wrong input, or other unforeseeable things. When an error occurs in C#, C# will normally stop and generate an error message. The technical term for this is exception. Try and catch keywords come in pairs. The try statement allows you to define a block of code to be tested for errors while it is being executed. The catch statement allows you to define a block of code to be executed if an error occurs in the try block. Let's consider this example where we create an array of 3 integers. And my num is equal to 1, 2, 3. So now we are going to intentionally access an index that does not exist in our array. Let's hit Ctrl F5 to run this. Unhandled exception. System.index out of range exception. Index was outside the bounds of the array. So if an error occurs, we can use try catch to catch the error and execute some code to handle it. In this example, we'll use the variable inside the catch block E together with the built-in message property, which outputs a message that describes the exception. So now let's use the try catch block to handle this exception. This is our code inside the try block. Let's use the catch statement to catch errors. Catch exception e.message. Let's hit Ctrl F5 to run our program. Index was outside the bounds of the array. No exception was thrown. We used the catch exception method to handle the exception. So the C#.NET framework has the exception class, which is this. So we used it to access the error and printed it in a very beautiful way. We handled the error very well. So this exception has a method called message that tries to get a message that describes the current exception that we are trying to handle. So in this way, our code will not be broken. So with this exception.message, you can also output your own message. If you don't want to use the actual exception message, you can say something went wrong. But this is a user-friendly error message. Hit Ctrl F5. Something went wrong. Now there is a finally statement. The finally statement lets you execute code after the try and catch, regardless of the result. So we can add a finally statement here. Finally CW. The try and catch. The try catch log has finished running. It's Ctrl F5. The try catch log has finished running. We also have what we call the throw keyword. The throw statement allows you to create a custom error. The throw statement is used together with an exception class. There are many exception classes available in C#. We have the arithmetic exception, we have the file not found exception, we have the index out of range exception, which is the one we just saw now, and we have the timeout exception. There are so many of them. So let's comment this out, highlight it, and hit Ctrl K, Ctrl C to comment it out. Now let's create another example. Let's create a method in our program class, say static void check age. And age. Now inside the method, we're going to check if age is less than 18. So we're going to throw new arithmetic exception. Let's give it a message. It says denied. It must be at least 18 years old. With semicolon, else access granted. You are old enough. Now let's call our method. Let's call our method check age, and let's give it 17 years old. I made a mistake. I used argument exception, so instead of arithmetic, so let's say arithmetic. There are so many exceptions in C#, so let's hit Ctrl F5 to run the program again. Having corrected the error or handled exception, system.arithmetic exception access denied. It must be at least 18 years old. What we did here was we provided our own interpretation of this exception by adding the message. So what if the age was, say, 19? Would you see the exception? Hit Ctrl F5 to run. Access granted, you are old enough. So that is how we handle exception in C#.